collide. Holding on to the stars of starlight. There's a light within the dark waves, guided by echoes of ancient ways. Unified one reflection. With every beat there's a connection. Feel the pulse, divine sensation. Everyone feels the goodness of our invitation. There's a light within the dark waves, guided by echoes of ancient ways. Unified one reflection. With every beat there's a connection. Feel the pulse, divine sensation.
What's going on, everybody? I'm back on for some fun with circuits on Saturday nights. So we're going to be going over a couple things, including a circuit simulation with a program called Crumb and possibly another piece of software. We're going to be specifically simulating the Bedini SG and seeing if we can monitor the wave pattern. Crumb isn't known to be specifically for simulating back EMF, but we're just going to look at the waveform anyways and see what it gives us. And we're also going to try to do the protection circuit in the simulator. And then we're going to move on to actually building the protection circuit with some of the components that I have, if we can. I don't have I think it requires a 6 ohm resistor. I only have a 10 ohm resistor. I hope that'll do. I sent the links out for the team. Hopefully somebody joins us, and we'll have somebody working with us on this. But in the meantime, I'm going to load up Crumb, and I'm going to show you how interesting this circuit simulator can be, how fun it can be simulating your circuits and trying to get an idea of your putting your idea to paper, pretty much. So let's load this up. I'm going to switch screens here. Move that over here. And we're going to load Crumb. All right. Now, this is Crumb. You can get it for, I don't remember how much I paid, like $8 or something on Steam. And it's very rudimentary, but it's very easy to use. I'll show you. It's very simple. So we're going to add a breadboard. And I'm going to switch back and forth here because we need to take a look at the protection circuit in a moment. But for now, let's do the Bedini SG. Let me actually load that diagram up as well. Present. Pictures. Downloads. There it is. Okay. All right, I just had to pull up the diagram for me. Unfortunately, I can't share it at the same time as Crumb, but it is available in my preliminary guide if you were paying attention last night to the link. The Bedini SG is in there. I will post that link in a second for you guys so you can follow along with the diagram on this, for this circuit. This might be it. Yes, this is it. Okay. Oh, it's not in here. Well, I'm going to post it and I'm going to put it in here real quick. So you guys should be able to see it in a moment. Just got to drop this in here real quick. I guess I meant to do that last night and I didn't. Oh, it was in my other one. It's okay. We'll put it in this one. Okay, so this is our preliminary guide. I'm going to drop it in chat right now. Here we go. All right, so that's the guide and the diagram that I'm using right now, if you want to follow along. It requires a 1N4007 transistor, but we're just going to use any transistor we can find if we can't find that exact one. And 1N4001 and one. I'm sorry, that's a diode. That's the diode. 1N4001 is also a diode, and the transistor is that's required is going to be a fast switching one. I'm not sure exactly which one is required for the circuit, but Mike said any fast switching transistor should work. So let's see. I have a 13009 on my board. MOSFET. So they actually, oh, there we go. Here we go. All right. So we're going to add a transistor. Right there. And you want to right click to pan and pan around the camera. And then the mouse wheel is to zoom in and out. And also, you have the WASD keys on your keyboard that you can maneuver the camera back and forth and side to side as well. So just some quick tips on how to maneuver the 3D camera. All right, we're going to want to put 2 power supplies. This is going to be a little unconventional because they don't have a battery power supply. So I don't honestly know if this is going to work, but we're going to try it anyways. Oh, these don't have the power rails. Okay, I was just wondering about that. I was like, okay, there's no power rail here. There it is. There's the power rail. I'm like, what the heck? Okay, here's the power rail. We're going to add 2 of those bad boys. And we're going to separate them so we don't get confused. One of them is going to be for our power battery. The other one's going to be for our charge battery. I assume in my head that's going to go, but it could go different depending on how our circuit looks on board. I'm not too experienced at putting together circuits, so just bear with me. We're going to put our charge battery to the positive end of the first coil. So we're going to need 2 inductor coils. Let's get all our components in order first. And I did some research on this, and apparently since we're replacing the coils with an inductor here, we're going to need to reduce the henries to a very, very small amount. I think it's 10 to 100 millihenries. So we're going to put in that right here. And we're going to add that component. Let's see. Let's flip it around. This little circle here, if you grab it, it allows you to flip it around at a different angle. And then the center square, or yeah, the center square turns blue. It should allow you to align it. Will it let me do that? Nope, won't let me do that. Okay, so we're going to put that here. And then we're going to... Oh, it won't let me do that, huh? What? It should let me. Yeah, there it is. Okay, I was going to say... So the reason why it wasn't letting me is because I had an extra space in there at the end. So just keep that in mind if you're using Chrome. I guess it's space sensitive. Let's move that a little over. We wanted easy access to the jumper jumper rail here, so I'm gonna move these. No. Okay, so here we have coil A and coil B, and in our rodent coil, these are wrapped together, so it's the same coil, only we have 4 leads on it, so essentially the same here. So we're going to work with that. Now we need that 2 diodes, and the transistor is already here. Where's the diode? Diode. All right. So we're going to need to do some calculations. We'll go to ChatGPT real quick to see how much it suggests for our diode here. All right, so we have a 10A10 diode that we're going to be using for protection circuit. This is a fat boy. The diodes for the SG are a little smaller. Do I not have them here? Yes, right here. Well, so this is the... Oh, no, that's the wrong one. Guess I don't have them. They're over by the lab. Okay, so we're going to ask ChatGPT how many... or how much voltage and leakage we were going to require for the Bedini SG. All right. So we asked ChatGPT, and it is suggesting that for the 1N4001, rated for 50 volts reverse voltage and 1 amp forward current, with a reverse leakage current typically around 5 amps at 25 degrees, but this can increase the temperature. Okay, so no, I don't know the expected peak reverse voltage of the setup. I do not. But the power battery is going to be 12 volts, 13 amp hours. And the charge battery is going to be the same. Okay, so here we go. 5UA. Okay. Oh, UA is microamp. Okay, so you need to convert that into amps. Okay, so for the 1N4007, we're going to do 5 microamps for the leakage. We're going to input that here. And then for the voltage, we're going to put 1000 volts. Hopefully this inputs like that, 1000. Nice. I think it worked. Okay, so that's our 4007. Now we need to do our 4001. And we're going to update. Okay. So this one's going to be 50 volts and the same leak current amperage, amperes. What the heck? Okay, there we go. Oh, did it not take? Let's see, 1000. Yes, okay, good. This one's at 50. All right. Oh, hey, what's up, Mike? What's up, Elijah? Yes. 4007 diodes. Yeah, I used to be a chat agent, Mike. So I used to have to type really, really fast for long periods. And the faster we typed, I hate to say it, but the more money we got. It was kind of like a dystopian reality for me. Just sitting there typing for, God, like 3 hours at a time nonstop and having a 10-minute break. Having to rush back to your keyboard because, 3 strikes and you're fired rule. If you're like 2 minutes late, it was crazy. Screw that company. Goobagoo can go to HE double hockey sticks. I can't say it. I can't curse. I want to, but I can't. Less ohms, less volts, I assume. Got to go. Yeah, Sax, I appreciate you stopping by. We'll see you soon. Yeah, good to see you, Elijah. Yeah, it was really terrible. People like were telling me in upper management because I was like, I was good at my job. Like I was constantly in the top like performance for the agents. So but upper management was telling me, like, oh, hey, everybody has pains in their hands and stuff, so if you don't hit upper management, and even if you do, like, you're gonna have some health problems typing like that. And I have like carpal tunnel, and I've already had like inflammation in my fingers, so it doesn't help. Hey, what's up, Mike? We got Mike Does in the house. Let's bring up this diagram and we'll complete this circuit. We got a resistor and a capacitor to put down. Oh God, what did we decide on the resistor? What is this? And the Bedini circuit I have here. What was that? 100 ohms? I think that was a 100 ohm resistor. Oh, sorry, Mike. Were you not able to?
Yeah, no, the camera's all messed up.
It's okay. Mine got messed up earlier and I couldn't fix it.
How's it going, man?
Pretty good. Just working on this circuit, trying to simulate it, and we'll see if we'll get any kind of wave signal, I guess, and see what happens. I doubt anything's gonna happen, but I just wanted to try it. I do want to do the protection circuit tonight, though, because that's on my agenda for tonight. It's my main goal, and I got these fat diodes to prove it.
Is that the what is that? The Bedini SG circuit or?
This right here that I'm working on, yeah, this is going to be the Bedini SG circuit. You can see the two coils here as inductors.
One of them's a trigger.
Yeah.
You don't really, yeah.
Oh, so you don't need it?
You don't really need it unless, well, not if you're using your own signal generator. You don't need the trigger winding. If you're going to trigger with a relay or a PWM, then you just one of the coils is the drive coil. They call that the drive coil. That's the coil that gets energized. The other coil is just wrapped around there to pick up the magnet that passes on the wheel to then trigger the transistor. But if you're
in this transistor, I'm trying to figure out the base is in the middle, right?
Yeah, I think so. Those look like the ones that have the base in the middle. Most of the time, they're in the middle.
Yeah, it's just the generic setup for it, I guess. And which one's the which is the front facing? Is this front facing?
The flat side is the front.
The flat side. Okay. So the collector's probably on the left, and then the emitter's probably on the right.
Well, what's the number of that diode? I mean, transistor.
It just says transistors come in two flavors, NPN and PNP. This is an NPN right here.
Yeah, it has to have a number on it. The part number?
Well, it just tells me the beta input for the transistor. That's it.
Oh, you mean it's the one from the program?
Yeah, this is from Crumb, from the simulator. The simulator is very limited, so we might not be able to do it, but I just wanted to try.
Yeah, it looks like a smaller transistor. The smaller types, the ones that handle less current, less voltage.
We got this MOSFET here too. N channel, P channel MOSFET.
MOSFETs are more higher power.
Should we be putting that on there then? Because it's pretty much the same thing, only like you said, higher power, right?
Look for this part number. I'll put it in the chat inside the program. If not, look for
yeah, it's very basic. It basically all the active components are diodes, Zener diode, which is probably like a it's not what I thought.
So on the one you're looking at now, the collector is usually on the left, and the base is in the middle, and the emitter's on the right.
Okay, yeah, that's what I thought. The small one, right?
Yeah, the one looking at it, looking at the flat side.
Yeah, and this is the collector, base, and then emitter. Okay. So we'll just use this for now and see what happens.
This is the most common one that I know of. 2N3904. That's probably what that is.
These are my jumper wires. Okay. So we need a resistor. What was that? 100 ohm resistor?
Yeah.
We used?
Well, no, that's only for the trigger winding. So if you're triggering with a pulse WM, you just put the pulse width modulator. The plus goes on the base and the minus goes on the emitter from your PWM.
So I don't think this has this doesn't have a PWM. It just has a signal generator.
Okay, 5 volts.
Yeah. Okay. So
Put the
5.
plus 5 volts goes on the base, negative 5 volts goes on the emitter from that signal generator.
So we don't need the resistor.
No, not if you're using a signal generator.
Okay.
93904.
And then I think the last component is. Nope, we got everything except the battery and the signal generator. So for this, do you think the signal generator would be our power battery, or will we just use 2 DC?
The signal
12 volt
generator
supplies?
is the well, I don't know what that program's giving you. Is it giving you a pulse width modulator, or what's it?
No, so it just has the 12-volt power supply and it has the 12-volt signal generator.
At whatever square wave and frequency or whatever?
Right, whatever you set it. And then it does have an integrated circuit, but
yeah, just send the plus of that signal generator to the base of your transistor and send the minus to the emitter of your transistor.
Okay, hold on. And the minus to the emitter. Okay, 1 second. Let me set this down. Oh, connect. You said the positive to the collector or the base?
To the base. No,
Positive
collector
to the
stays
base.
out of this for now. Just the base and the emitter. Put the plus of the signal, 5 volt signal, plus, what is it, 2 to 5 volts? Put that plus voltage on the base and put the negative voltage on the emitter.
Nice. There we go. I just got to turn it around so it's not all finish. So we turn this around like this. There we go. Okay, cool. So now, yeah, the positive's on the base, negative's on the emitter. And I just want to turn this on real quick while we have it set up, because it won't let you turn it on until you wire it. Let's see what we can do. Oh, this is cool. Oh, nice. So you can set the hertz and the waveform too. This
right. Now listen here. So what you do now is you put the you put one end of the coil on the emitter. I'm sorry, no. You're going to trigger the negative from the power supply to the coil. So you put one end of the coil goes to the positive of your power supply, straight to it. So what's the ohms on that coil, by the way? 5 ohms or something?
So we have 10 millihenries.
Yeah, but the ohms.
Yeah, I don't. It only says the inductance in millihen. Oh, you're talking about
resistance, ohms. It should tell you the ohms on that coil.
Yeah, no, it just says inductance for the inductor.
Let me see. Hold on.
But like I said, this program is very rudimentary. It's probably like somebody's pet project, I can imagine. How do I move this?
Inductor impedance. Okay. Look at this.
Here.
Wow. You said it was 10 millihenries? 10 millihenries.
Yeah. Yeah, 10 to 100 it recommended.
Was that 0.001 Henry?
So I got hold on, let me look at my notes. 0.00001.
0.00001.
Yeah.
And what frequency are you pulsing at?
I wasn't sure what we were going to pulse it at.
100 hertz. 0.01 ohms. That's a very low ohms on that coil. So, yeah, and let's look at the transistor too. The specs on this transistor. It's see what kind of voltage you can give it. But that program will probably tell you when you're going over voltage. Try giving it, well, you're going to give it the signal at the base and the emitter, but across the collector and emitter is going to be connecting the negative rail to the power supply and the coil. And one end of the coil is connected to the plus of the power supply. And you are going to switch the other end of the coil through the negative side. You can do it vice versa, but for now, let's switch the negative end. So connect the positive to one end of the coil and connect the negative from your power supply. Like connect the positive of your power supply to one end of the coil. And then connect the negative of the power supply to the collector.
Okay, give me 1 second. Let me adjust this. Oh, sorry. Did the positive to the hold on. You said positive of the power supply to one end of the coil?
Yeah.
Okay, so we're gonna just put the power supply on the rail, make it a little easier. Okay, so it's both there. Finish. Let's drag this around so we can see a little better. Oh.
Right. This is a perfect little thing.
It's a neat program. I hope we can get something out of it. Some kind of signal, you know.
So the negative of your power supply goes to the emitter, and the other end of the coil goes to the collector.
You know what I'm just realizing, though? This doesn't have an oscilloscope, I don't think. We have a serial monitor, though.
Right. But we're just setting up a standard pulsing the coil setup, and then...
Yeah, we can always test it with an LED or something, I think.
What, do you got two power supplies there?
A buzzer. No, so this is the signal generator, and this is the power supply. So we're going to hook one end of the coil up to the power supply.
Yeah,
and
the
then you said
positive of the power supply goes to one end of the coil.
And then the other end of the coil
goes to the other end goes to the other end of the coil connects to the emitter.
Okay.
I'm sorry, the other end of the coil connects to the collector.
Collector.
And the negative of the power supply connects to the emitter.
Okay. And does that matter if this is first or this is second in that instance, since it's a negative? It might not.
Kind of, because of the emitter, it sends plus in one direction towards the negative. So if you look at the schematic of a diode of a transistor, you'll see that the emitter is like a diode facing towards the away from the no, you want, it does matter.
So should I put this first closer to the transistor or farther away?
Which connection?
So I'm connecting the negative of the power supply to the emitter. To the emitter. And then the signal generator is already here connected to the emitter.
Right. The negative portion of the signal generator.
Yeah, which one should go first? The signal generator should be closer to the transistor, or the power
supply? Both the negative of the signal generator and
it doesn't matter because it's a negative, right?
Right.
Okay, I just wanted to make sure. I wasn't positive on that. So it doesn't matter that order, but sometimes the order does matter depending on the component that's there.
Well, you need the on the signal, you have a plus and a minus with any signal. The plus has to hit the base and the minus has to hit the emitter to trigger that transistor to close the gate. If you don't hit the base and the emitter on that transistor with the plus and the minus of that signal from the generator, the transistor is not going to close its switch. It's going to stay inactive. So every time you hit the base with low voltage and the emitter with the negative side of that same low voltage, because every voltage has a plus and a minus. So that has to go across the base and the emitter, plus and minus. And that will trigger the switch on that transistor to close the gate between the collector and the emitter. which will create a short between those 2 points and allow power to flow from the plus terminal of the power supply through the coil into the negative terminal of the power supply. But it will do it at a switching speed of your choosing, because you're controlling the signal speed, the on and off speed of the transistor. You control that with your signal generator, your frequency and your duty cycle. You can control how much amps goes through the collector emitter junction. You can control the speed of the switching. You can control the time that the switch stays down and the time that the switch stays open. So it's a pretty handy setup. It's the most dynamic switch you can have, pretty much.
So I got this these 2 diodes here. This one that's highlighted is the 4007, the one that's supposed to be connected to the charge.
Right, we'll go into that. Are you done wiring everything already? Like the
Yeah,
signal
everything
generator?
should be good to go here. I think the
So
only thing we need is the diodes, right?
Right. So
And
you
the
wanna
capacitor.
add-
I'm sorry, the capacitor.
do you want to add the charge battery to this circuit? Because it's not in there yet. Right now you have the source power.
Yeah, well, I mean, we can add the charge battery. I'm not sure what it'll do though. Just maybe as a load. It's not going to tell us anything.
It'll take the flyback coming off that coil in the reverse polarity.
Yeah, let's just see what it does. Okay, so we'll add another one.
So put like a 12-volt battery in there, or whatever it gives you, the circuit, the program.
Yeah, it's just a 12-volt
It can
power
give you a
supply
capacitor.
again.
No, not a power supply. It has to be a capacitor. Make it a capacitor.
Capacitor, okay.
If you
So
can't
here's
make it
our
a battery,
capacitors.
just turn it into like the
Oh,
biggest capacitor you can find inside the program.
that's a good idea. No, it's a good idea. So we have a host of selections here
What's up,
for
Bill?
scales. Yeah, how you doing, everybody?
I'm here in the
Sorry,
background.
I haven't really been paying attention to chat because it's on the other window. Usually I have it in front of me. So there's a MF. It seems to be our biggest scale.
Microfarad, yeah. Get the highest number you can get on that with the highest voltage rating you can get.
It says MF, UF, NF, and PF.
MF.
MF, okay. And then the highest one we can do, which is probably, I don't know, let's do 1,000.
Whatever it gives you. Yeah. And voltage as high as you can get on the program. What's up, SAQ? Okay.
Okay, that's the negative. Okay.
And add the 4007. You can put that in there too.
Should we make it polarized or the ceramic?
It's a polarized, yeah.
Polarized, okay. And I set it to, looks like 100,000 volts.
Nah, 10,000 microfarad. 100.
I'm sorry, not volts, microfarad. Yeah. But what you think that'll be okay? 10,000.
Yeah, get whatever the highest voltage you can get. I don't know.
I could just keep on putting in zeros, and I don't know how long it'll.
I think try.
Yeah, I could do as much as we want.
Okay, then put it to 1500 volts.
What does that translate
going
into?
more than that.
Hold on, let me translate that to microfarad. So 1500 volts.
I don't think they make a capacitor like that, but it's just so you can see the readouts.
Right. I mean, it's just simulating, so.
And the program should simulate the flyback because it is a technical part of electronics, you know.
ChatGPT says you can't directly convert them.
Convert what?
Microfarads straight forward to volts.
No, just in the program. See what high voltage it lets you choose. Choose the highest one offers
Oh,
you.
you can't see it? No, it doesn't let you. It just says capacitance. That's it. That's
It
the
doesn't
only
give you a
option it gives
voltage
you.
on there?
No, not for the capacitor.
Oh, right, then just choose whatever the high microfarad you got now, and put it in there. And then you can add a voltmeter to that capacitor across it.
Okay, let's see. Man, they don't even have a voltmeter in here. I'm realizing they're missing a lot of components in the Chrome.
You should be able to read the voltage.
We might. I mean, if it doesn't work, we might have to switch to another app. Really.
Test points, or maybe it's called something else. Lead points, or
okay. So we have the capacitor in here. The negative of the capacitor is going to go to, it looks like, positive end of channel A for the coil on my diagram. So how do we convert that to the single coil? So the trigger coil is not necessary. So that's channel B, I think, right?
Yeah, you don't need the trigger coil because you have the signal generator. See, Bedini was using a trigger coil for the wheel system, the wheel with the magnets, because the magnet on the wheel would trigger the trigger coil with a magnetic field from the magnet to make your signal at the timing.
So the trigger coil is the one that's hooked up to the transistor, or is that the one
trigger coil was just creating the signal generator. It was just replacing what a signal generator does. It was just, see, the magnets on the wheel were turning and pulsing over the coil, making a signal pulse.
Okay, I'm just trying to get a idea of which coil we're getting rid of in the diagram. So
that's the trigger coil.
Yeah, but the trigger coil is the one on the left of the diagram, right? Because the one that's not hooked up to the transistor.
Hold on a second.
Yeah, I believe it is. It's the one on the left. So we're going to be using this, and then the other end of that, yeah, it goes to the power. Okay. So the capacitor is just going to be straight up connected to the negative of our power rail. Okay. Okay.
No,
that's just going to be.
Don't hook up the capacitor to the power supply. That's not going there. That's going somewhere else. That's going to be connected to the high voltage diode and the coil. So.
Oh, right here. Okay. So the high voltage diode is what? The 4007?
Yeah. So put let me tell you how to hook that up. That is the 4007. You want to face it away, connected to the collector of the transistor, facing away, which is the same point that one end of your coil is connected.
Oh, so not the stripe, and the other end is going to be connected to the transistor?
Yeah.
So the black end.
The stripe should be facing away from the collector.
Okay, and then the black end
and the other end of that diode is going to face towards the positive terminal of the capacitor you just added.
Okay. Wait, hold on. So say that one more time.
Can we look at a circuit here to see what I'm following? It's the Bedini.
Yes, you can pull something up. Oh, here we go. You got something.
Oh, no, that's the wrong thing.
So pull something up real quick, and I'm gonna try to fix this diode because it's oriented in the wrong direction. So you want the stripe facing away from the collector, you said.
Well, the stripe is
just to give, like, it doesn't need to be, but just
if you have a stripe, if that's the stripe, the arrow is pointing at the stripe. So the stripe is on the one side of the diode, right?
But is that connected to the collector?
Hold on. You got a stripe on that diode, right? It's not, the stripe is not in the middle of the diode. It's on one side or the other, right?
Yeah.
Okay, the side that the
Ooh,
stripe is on is the side that the arrow is pointing towards.
Oh,
So
I
when
know.
you,
I'm saying, do you want me to hook up the diode directly to the collector? Is that what I'm doing here with this diode?
let
Like,
me
am I
share
hooking
the
it?
screen. Where is it? Where'd it go? It's right there. Okay. Hold on. Give me a minute here. I gotta capture this image. I'm following the Bedini window motor. It's enough to use for this, you know.
Mm-hmm. Let me put the capacitor on here.
I found
too.
it online. Save image. Okay. Now I'm gonna bring it up.
Oh, that's right, because this is a charge battery. Okay, so I do have the old diagram. We're just changing it a little bit, and it was confusing for me. I got the two capacitors confused because we're using this capacitor as a charge battery. Okay, so that makes more sense, and that's in the right direction now. Okay, that's connected here. Yeah, and that
Right,
should
right.
be connected right to the collector. Okay, yeah, so this should be connected to the collector.
Slow down. Just go ahead, connect it how you think it should be, and we'll go over it.
Mm-hmm. Because I'm wondering now, like, I can connect it on either side, or should I connect it in between?
Can you? Okay, so hold on. Let me present this. There it is. Okay, I'm sharing the screen now. So you can see that. I'm gonna show you where you're at now.
No, here we go. Okay, yeah, I'm right there, right where the charge battery and the coil that we got rid of is.
That's your coil, right?
Or no, not the coil that we got rid of. The coil that's on there. Yeah,
That's the
that
coil
should
you
be
got
okay.
rid of.
That's the coil. Yeah, that's the coil we got rid of.
You don't need to pay attention to any of this stuff. So you have this coil in there right now, and you have this diode. That's the 1N4007. That's the one you're working with right now, and this is your capacitor.
Okay, and that's in between the coil and the transistor, I see. So that connection for the diode needs to be in between, it looks like.
Right. So connect the
Okay.
diode facing away from the collector.
Let me move.
One end of the diode connects to the collector, and it faces away from there towards the positive of the battery. So you want that diode to point at the positive terminal of your capacitor.
Oh, the positive terminal. I had it backwards.
Yeah, I know, it's okay.
So
We all do that. We
Okay,
always hook
so
stuff up backwards the first time.
So this diode needs to be facing the positive of the capacitor.
Mm-hmm.
Okay.
Right.
Give me 1 second to straighten this up. Put a jumper cable for the diode here.
I don't see
And then that's the collector. And then we're going to flip this capacitor around so it's facing. Here, let me actually add this real quick so you can see too what I'm doing. So we're going to delete this and we're going to put another one on right here. Like that. Awesome. I think that's it.
Right. Okay. So the negative side of that capacitor goes to the, if you look at the schematic, goes to the other end of the coil, the side of the coil that's connected to the plus side of your power supply.
Let's see. Yes, the power supply. Yep, you're right. Yep. Just making sure I connect everything because I need to be able to read these diagrams and I'm not the best at it yet. So, okay. So we're connecting to the positive of the power rail, that negative. Okay. Okay. I see what you did here, Bedini. Not really.
You will.
I
It'll make
will.
sense. Eventually, it'll make sense.
That's the wrong.
You're using the transistor to energize that coil in a on-off pulse fashion. To create the spike, which requires an off portion, and you need to turn off the power to the coil for that event to happen.
Where exactly should I plug this in on the power rail, though? This needs to go like right at the start. Yeah, okay. So it's in a good position here.
So the battery on your left is your power supply. The one on the right is your capacitor.
Mm-hmm. Hold on. It's not letting me turn it on anymore. Oh, here we go. Scope. Oh, it does have a scope. Nice. Okay, so there we go. Okay, so we're turning on the power supply. It's at 5 volts, no amps. So it's not getting any amperage. So it's not detecting any kind of load. I'm going to turn on the signal generator. We got 5 volts and 20 hertz right now as the default. And I switched it to square waveform. So you said how many volts? I know you said like 100 kilovolts or 100. I think it was 100.
I'm hunting volts on what? What are the capacitor or what? What are you talking about?
The signal generator. What are we setting it at?
5. Yeah, just put it at 2 volts.
Oh, 2 volts. Let's see.
Yeah.
All right.
2 to 5 volts.
And the hertz. We're gonna up that. Warning: circuit error. Solve fail. At 100 hertz. Oh, here's the scope. I can see the scope
What's
now.
your source power on that?
The source power is 5 volts, and it's getting negative 34 milliamps.
So
It
look
says
at this.
negative
Look at the
34.
drawing here. You see the signal generator, plus and minus.
Hold on, let me bring
That's
it up
obviously hooked up, right?
again.
Right. I'm just deleting all the stuff that's going to be in the way here.
Well, I was assuming that it might give us an error like this just because it's an unconventional setup, right?
Yeah, it might. Yeah, because it's flyback. You know, like I don't know if
But the
these
fact that it's
programs are designed to calculate flyback.
yeah, the fact that it's giving us a negative reading on the milliamps though is interesting, I think.
Hold on. Look, let's make sure you got this wired up just like you see it here. Your one coil, your capacitor on your right, and your power supply on the left. The diode there's only one diode going on here, and that's the high voltage N1N4007. And you can see SIG is your signal generator, plus on the base, minus on the emitter. And that will just allow the negative side of the power supply to connect to that coil and allow the coil to get energized, because the plus side of the power supply is already connected to the coil. It's jumped. You're just switching the negative of the power supply to create a pulse. And the flyback, okay, so there's your plus from the power supply hitting the coil is right here.
Dude, it says jumper wire current rating exceeding 7 amps at 22 hertz and 2 volt input on our power.
That's because the coil,
our signal generator.
Okay, put it down. Put your source voltage down to 2 volts.
Crazy. Yeah, it's at 2 volts, but at 22 hertz. I'm just saying what the error says.
Not the signal voltage, the power supply
Oh, the
voltage.
power supply. Okay. Put that down to 2 volts. Oh. Holy crap. Look at that. Let's take a look at the scope.
So look at the drawing here. This is
I
how
don't see
you're
anything
on
on
the
the
left side. You see the plus and minus. That's the polarity you give in that coil from your battery. But on the right side of the coil, I'm going to put the flyback polarity, and you can see how it would go into the capacitor.
That's crazy.
You
This
can
is
see the diode
insane.
is there, and the negative. And
Look at
so
all that amperage it's drawn just from those 2 volts, though. That's awesome.
well, because your coil is only like it's got like 1 ohm or something. It's a low resistance coil. It's going to take a lot of amps. That coil is what I'm saying.
This is pretty cool, but we're not picking up anything on the scope, though. That's what I was concerned about. Look, all of our wires, nothing.
Because you're not switching. I'm pretty sure you're not switching that transistor. You probably have something not wired right. Check the diagram I have on the screen. Make sure it's set up the same way on that program.
And it shouldn't matter what hertz we set it to?
No, I don't think you're switching. It looks like if you've seen a straight line, that means you're not switching. You should see. You shouldn't be seeing.
Yeah, it says circuit error, solve fail. Let's see.
Is your signal generator set to a square wave or something like that?
Yeah, it is.
A 2 volt square wave. Try 5 volts. Maybe that transistor needs more than 2 volts. Some of them need 2.5 volts. Depends on the specs. Like I said, I don't know the model number or the part number of that transistor.
Yeah.
Put it at 5 volts, the signal generator voltage, just the voltage. And try it again. So the signal generator is on the left?
Yes.
And then look at the scope with it at 5 volts. What's your frequency on that?
1 hertz we're doing.
That's kind of slow.
It says at 1 hertz, it says warning, jumper wire current rating exceeding 7 amps, which is interesting. And then we increase it anything above 1 hertz, it looks like, then it gives us an error. Oh, hold on. Yeah, something in the circuit error, solve fail.
You just had a dip in the
Oh, yeah, we got a spike.
Speed up the frequency.
Oh, here we go. Yeah, we're getting spikes. Well, this is interesting.
Put it at like 300 hertz or 200.
Oh, that's cool. And what exactly what should we be monitoring here? The which wire? The one
your oscilloscope, change the settings to get closer in on the reading. Something's not right.
Okay, so let's monitor the capacitor.
What was this called again? Crumb? Right, from the
it's called Crumb. Oh. 5.
Well, what do you have a duty cycle setting on that signal generator? Can you set the duty cycle? Or you got 3 knobs there. Can you tell me what they are?
Oh, the waveform, voltage, and hertz. That's it. It's very simple.
Okay, which waveform are you on now?
Square waveform.
And the hertz. Okay. So I guess there's no duty cycle setting on that?
No, unfortunately. I'm about to move on to the next circuit actually, because we actually got a reading on our oscilloscope, and that's all I wanted to do is see what it would show us. We got these spikes as soon as we switch our hertz. You know, they're kind of almost like transient spikes, only for a second. You know,
Bring it up to 1,000 hertz.
oh,
You should see a lot more
baby.
activity in there.
Yeah.
I think it's a 50% duty cycle by default or something.
Look at that. I'm switching it to the waveform, and it's giving me like this spike. And that's a sine waveform.
Yeah, you look like you're having fun with this program, but I don't think the program's quite that accurate.
No, it's not. What's not made, that's the warning I put at the beginning of this live stream, is this program isn't really made to handle or simulate back EMF. So it's very rudimentary. I just wanted to see if we could get anything to show on this.
If you can read the capacitor, you should put a reading on the capacitor. It should be.
Yeah, that's what I was reading, and it was spiking.
Maybe
which is interesting, right?
Take the capacitor out, and you'll see more spikes. I think the capacitor is absorbing all the signal. That's why you're not seeing anything.
Just delete the capacitor.
Yeah, but leave the
Don't
circuit
rewire
as it is. Yeah, it'll be like the coil will be flying back into nothing. You won't have nowhere to go to fly back, and your signal will be still there. Otherwise, the capacitor will absorb the signal, and you won't see it in the oscilloscope. So if I wanted to,
oh wow!
There you go.
You see that? That was a large spike. Look at this. Look at how much more.
So yeah, those are the spikes.
Oh my god!
So if I wanted to see that signal, I had to remove the charge battery.
Fucking genius. Sorry,
yeah, the capacitor was absorbing the signal the whole time. But you should be able to read the voltage on that capacitor and see the voltage rise in that program. You should be able to put a voltmeter on the capacitor and see it actually rise in voltage from the spike charging it.
Right. Wait, say that again?
The spike will charge up the capacitor the same way it charges up a battery, and the voltage should rise. Assuming you place a voltmeter across it, you would see the voltmeter go up in voltage. That's a very rudimentary method of generating. It's the same way that the buck boost converters are creating high voltage and converting low voltage DC into high voltage DC.
It's lighting up. It's lighting up the diode.
Oh, you put a diode in there.
Yeah. Just to see.
Put the green diode.
Yeah. The green one.
It's easier to see the green, yes.
It is. You're right. Green. Here we go. Yeah. Yeah, baby. All right.
You sure you got the diode the right direction?
Yeah. Oh, look at that. Look at that. So we're monitoring. Is that just one component?
Well, right now the diode is
just the LED.
The LED is a diode, so it's going to rectify the flyback. You know.
Look at that, though. That's the positive and the negative it's showing. That's crazy. That's awesome. That's what I wanted to see. That's exactly what I wanted to see.
How high in frequency does it go? Can you go higher than 1K or 10K?
Yeah, let's see. 1700, 2300.
The green LED looks like it's getting brighter.
Dang, how far we can go with this? 6200 hertz.
You can see your signals are more often. Those are the signals that the LED couldn't capture. Remove the LED now and watch how many signals show up.
Let's see.
But doing this could damage your transistor in reality, but in the simulator,
right. That's why I wanted to do the simulator, because I can't damage the components like this, you know?
Right.
Exactly. So
Well,
let's
this
monitor
also-
this on the output of the transistor to the diode.
Yeah, you want to put the oscilloscope probe points are on the collector and the emitter. There you go. Let's see.
Yeah, right here. A collector and the emitter.
Yeah.
Let's see. I could put one on the emitter too.
One, you got two probes. One goes on the collector, one goes on the emitter.
Thought I could select the. Oh, maybe it just does it automatically. I don't know. But it's reading it. Yeah, jumper wires. It connected the negative automatically, I guess.
So yeah, because it knows. Yeah.
Yeah, it's weird. I don't know. But I'm gonna see how far this can go up. Oh wow. That's crazy. Yeah, we're at 9,900.
That is the spike signal, though. So
Yeah, right?
It looks like the circuit does know how to compute for.
Yeah, like it's registering because it's using conventional, electrical engineering principles, right?
Mm-hmm. Well, yeah, the 5-back is conventional.
They just ground
Conventionally
it out.
known.
They ignore it. Yeah.
It's not
So this is
widely
cool.
talked about.
But this is so cool, Mike. Like we're sitting here and we're showing everybody like this is the spike we're looking for, you know? I mean, we can't really zoom in with the scope a little bit, but I'm sure if we zoomed in, we would see probably an H wave or something similar, you know?
Well, you slow down the frequency, you'll see the H wave show up.
Let's see. Yeah, let's try it real quick before I switch to the other circuit.
There you go, a steady fly back there. Yep.
Dang, this is gonna take forever. Give me a second. Well, no, it's because it only happens when I switch the frequency, Mike. See, I stop and it stops. So I switch it, I go down or up, and it just gives me those spikes. It's crazy. This is so cool. But I'm just trying to
Well, you're
it's
at a very
kind of
high frequency, like maybe 10K or 5K. You're at 65.
But yeah, you're right. It seems to be zooming in a little bit. Let's see. Let's see how low we can go. This is insane. This is so cool. I was not expecting this to actually work. I was not. I'm going to tell you straight up. I was expecting this to be an epic fail.
Well, I am a CET certified, so
if you didn't show up, I probably wouldn't have hooked it up correctly, to be honest. So I'm glad. I'm grateful you showed up. Thank you. All right, we're at 30.
Steady flow there.
Yeah. Well, it stops as soon as I stop changing the frequency, but it looks like the signal is getting bigger. You know, like we can see it a little better. Right now we're at 2,400.
That sounds like a glitch in the program.
Maybe
When you're not turning the knob, maybe you're not setting it to something. I don't know. Maybe it's a setting. Why is that the right side moving? The right side is the power supply.
Oh, because I'm switching. Every time I switch the frequency, it moves. It's changing. I didn't notice that. So I switch it back. See how it spikes for a second, and then this moves.
Put it at 1 volt. The power.
We're gonna lower it. We're gonna see. Oh,
you got a very low ohm coil there. Very low ohms on that coil. So maybe it's override.
Oh wow! I changed the voltage and it spiked again. Let's go down to
0.5 volts.
Oh, look at that. That was weird. Look at this. This is cool. So is it
glitching anymore at 0.5 volts? Is it still glitching at the low voltage?
No, it just keeps on going up and down on the power
do you
supply.
have to move it to get a signal? And will it make a steady signal?
Oh no, it's not making a steady signal. But I think that's just because we don't have a charged battery on it or a load or something, right?
Maybe, right. You could put a resistor there. Put a
resistor
where you had the LED. Put a like a 1K ohm.
Okay, so 1,000 ohm resistor.
Yeah, give it a small load so it
Where the
maybe that's
capacitor
what's
was, you said?
yeah, yeah. Well, where you had switched the capacitor for the diode, same place.
Okay. Oh, I put that on and it did something
Now put the
for a
voltage back
second.
up to like 5 volts.
5 volts. Doesn't seem to be steady. The spikes are a lot less frequent too.
Do you have to do anything for the signal to stay there?
Yeah, it's not steady.
That's a
No
1K
matter what
ohm?
it. Yeah, it's a 1K ohm.
1 watt? Do they have setting? Tell you the watt of that?
Yeah, they do have a setting for it. Here, 1 second. Yes, it's 0.25 watts. So 1 watt
Yeah.
to 1 watt. Okay, we're going to update that. Go on to the oscilloscope. Change the frequency. We're at 31 hertz. The spike is more square wave now.
Keep it at like 5K or like 3K, so you can get a.
The resistor?
No, the frequency.
Oh, 5K or 3K. Let's see. And it's drawing 1 milliamp.
You didn't get that reading before with the quarter watt because it probably couldn't handle the quarter watts. Resistors burn out.
But the biggest spikes we seen were when we had
no load.
Just nothing. Yeah, just nothing here. Which is crazy wild to see that on this simulator. We're going to monitor that and we're going to do it again.
Okay, as soon as you put a load on the coil, those spikes get absorbed. Doesn't matter what the load is. You see, there you go. What'd you do?
But we can see the waveform. We just took away the resistor. We can see that. It's so cool. We can see that waveform on here. It's not precise, obviously, but it's still showing us.
5 volts is your signal. Bring it down like 3 volts on the signal. Maybe too powerful on them.
Oh, 3 volts on the signal?
Yeah.
Let's see.
2 to 3 volts. I mean, 3 volts is good. 5 volts is like full blast on a transistor. 2 volts is minimum. It's like.
Oh, that lasted a little longer on that.
And you are 5 volts on the power supply.
Hey, Ben.
Hey, what's up, Nathan?
Yeah, your voltage is still high though for that ohms coil. You want it like just like 1 or 2 volts for that. Unless you can add more ohms to that coil, be better.
Hey, Ben.
Hey, what's up? How you doing?
Hey, you guys are killing me here. This is DC voltage.
Right. Of course it is. The power supply is DC.
Okay, hold on. You're putting in DC voltage. You're looking for a square wave. It's around 50 hertz or less. You got a couple square waves. Then you tried to put in AC frequency, which is way too high for DC power.
No, he's using the square wave.
Yeah, it's a square.
Not at 3,000 hertz.
Oh, we were putting it all over the place.
You have no duration that's correct in here. There's not supposed to be a spike. It's supposed to be a square wave duration wave.
Well, we're not reading this. The oscilloscope is not hooked up to the signal generator. It's hooked up to the coil.
And this simulator really isn't made for back EMF, so I wasn't expecting to get any signal, to be honest. I just wanted to get a signal.
Right. The back EMF is not coming from the square wave. It's coming from the coil that received the square wave at first, and then
There is no flyback coil here. There's two inductors.
the one coil is the one coil that we're driving to create the flyback.
Where's
This
the
one is
coil?
this one isn't even hooked up.
Those are inductors.
Yeah, this one isn't even
Yeah,
hooked
the
up.
other
Though.
one's not even part of it. He just got it sitting there.
But it's not a flyback, it's an inductor. They work differently.
Right.
You have a DC system right here. There's no AC in this. You have to run it as a DC system.
Yeah, so he's just trying to replicate the Bedini SG. It's a DC system, the Bedini.
Yeah, it
SG.
gives us a good visual of how we might set something up on our breadboard.
He's trying to simulate the flyback from the Bedini SG circuit, which is a DC system. It's not at all an AC system. So I wouldn't worry about that.
Bad habits lead to bad things. You have to do it the right way.
So I'll close that window. Oh, what you doing there, Ben? Got a lot of signals there.
I'm just bringing it down because when we were in the lower frequency, we actually got almost a perfect square on our waveform.
Because it's DC,
Well, you could hook up
around 50 hertz.
if you want to
Start there
measure
and
the
work
square
down.
wave. If you want to measure the square waves, move the probes from your oscilloscope over to the signal generator, which is the base and the emitter points. So put the positive probe on the base and the negative probe on the emitter.
Just put it
And
down to 50 hertz.
And you will see the square wave show up on there, not the spike. Thank you. Base and emitter terminals from the oscilloscope.
Okay, now turn it down slowly, Ben.
Oh, there we go. It's a larger spike there.
Turn it, just hold it for a little while, see what it does.
There you go, Ben.
You got to
You
square.
got it.
See, I told you. You can't
Ben's
keep
got it
moving
all under control. I think this is Ben. Ben gets the credit here. I'm telling you right
Oh,
now.
look
Ben
at
did all
that.
this hard work, and so let him fiddle around here, and he's getting there. He's
Yeah,
figuring
but
it.
you're reading the voltage change in the circuit. You're not reading what you're putting in.
Yeah, he
Well,
knows
when
that.
we dropped it
He's
down
well
to
aware of that.
50, when we dropped it down to 50, it made that. What was that? Let me show
You
you.
can
It
see
made
what he's
that really
putting in.
weird.
It's written on the screen there, and the LED shows what the signal generator is putting in. He doesn't need to put the oscilloscope there unless he wants to see the square wave. But
And then I drop it down a little more.
I'm pretty
Hold on.
sure he can't change the duty cycle on this program. So
Just leave it for a minute, Ben, and read the signal. You keep moving it around everywhere. You're only okay. You're reading the difference in when you change the energy. You're not reading the proper part.
That's
think
the
what-
waveform I was looking for. That 20 hertz. There we go. When I saw that, I was like, what the heck? It only happens when you
Yeah.
adjust something like the hertz or the volts.
these programs are not gonna. The oscilloscopes like
Yeah,
these, I don't know.
I know
Kinda-
it's probably not accurate at all, but it was fun to do at least. I'm going to move on to the protection circuit though, because that might be a little bit simpler to do in here. Let's see. So we're going to get rid of that. I'm going to keep the power supply. Delete that. so I have, let me take this down. I have Nathan's section of last night's live stream where he goes over the protection circuit. Where is it? Oh, there it is. So that is
Hey, Lulu.
tab. I'm going to present.
What was that then?
Oh, I'm bringing up what was it? The live stream we did yesterday. There it is. Where Nathan was going over the protection circuit.
That's kind of the main goal here. And it's not to amplify.
And I do have all the components, it looks like. I have 270 ohm resistors I can put in, together. But the only thing is I don't have a 4 ohm resistor. I have the lowest I have is a 10 ohm.
And where is it that you want to use that resistor?
Yeah, right here. I was going to ask Nathan about that. If he thought that a 10 ohm resistor would work there. But we'll try it anyways. Because it's the only thing I have, really.
We're
So
across the
hopefully it works.
emitter and collector, or?
No, so this is between the stereo amp and the emitter.
Oh, that's something else I'm not aware of.
Yeah, this is just a little circuit to protect the stereo amp receiver from the back EMF going and blowing something.
Right.
So you see the coil here, the transistor, and the two resistors, and the diode here. I have the diode and the resistors and the exact transistor we need. So right here, ready to go. Actually, we don't even need to use the prompt. We could just build it right here on camera, because that would probably be simpler than
Ben,
using
what does
that
beneficence
program.
mean?
So
I've never heard
are you
that word.
familiar with the term maleficent?
I've heard the word maleficent once, maybe.
So it means basically evil doing. Like you have bad intentions.
Is it spelled Beneficen?
Benefencence, I believe. I could be wrong.
Well, I did the spell check, and it says Beneficence.
Yes, that's right. Yep. But anyways, it's the opposite. It's the antonym
right.
of maleficent. So beneficent is good intentioned.
Right. I'm going to stream this to my channel. It should be there. Thank you.
It looks like, so we have these transistors go base. When you're looking at them front on, they go base first on the left, then collector, then the emitter, I believe. So I can pull up that diagram real quick to double check.
Okay.
Yep, base, collector, then the emitter. So we're going to put this, and the collector, I guess, isn't hooked up to anything. We don't need to hook the collector up to anything.
Which circuit is this? Different one?
No, yeah, this is a protection circuit.
Oh, yeah, I don't know. I claim to say I do not know.
Well, it doesn't look too different.
That's my claim to fame. I'm the one man on the internet that will say I do not know.
So
I don't know something.
Okay, so that's the channel A of the coil that it's hooked up to. Okay, I think I understand this.
This seems like this is a different setup. It looks like.
Yeah, this is. Oh, so the positive of the coil goes to the emitter too. Okay, I see. Wait, hold on. No, okay. No, I'm getting the wire.
Does this circuit have a name? Like the name of the circuit?
Yeah, it's just Gerald's stereo circuit. So the coil goes, one end of the coil goes to the diode, That's channel A, I believe. Yeah, because it's protecting the stereo. And the other end.
I can't see that, Ben. I mean, I'm sorry, I just can't see it. It's too small.
Oh, let me blow it up. So it looks like there's a third wire going off the coil, though, to the emitter, unless I'm seeing that wrong.
I see a switch on the right. Is that what that is? Diode on the left, transistor in the middle. What is the thing on the right? I forget. The signal generator? I'm not familiar with this. This looks like something I haven't seen before.
Circuit, anything else, your back EMF that's created because of where he puts the power in will automatically amplify the circuit.
Is that a diode on the very left between the coil?
Gerald was using the.
There was another picture I thought he had of it.
Yeah. AC, DC, DC, AC. I don't know. I don't get hung up on the difference. It's pretty clear to me already, but yeah.
All right. So we're just gonna go with Mike, you said there's a switch that you saw in this the circuit somewhere?
I see the transistor on the top there. I see on the right looks like a signal generator.
Oh, you're talking about the transistor. Okay. Yeah, so that's a transistor and then a resistor and then the stereo. But on the other
the
side of the stereo, it's positive. And see where the positive leads?
If the positive is hitting the base of the transistor, that's where it's supposed to be. And yeah.
But you see right next to it on the coil, there's another line that's coming out to the emitter. Is that the load?
I mean, looking at it from where I'm sitting, it's the size of a dime, Ben. I'm being honest. I can't see it. Okay, I can see the positive coming out of the stereo going into. Can you zoom into the coil part where the positive touches the coil there?
Actually, I'm going to take a screenshot and zoom in. Yes, give me 1 second. I'll zoom in this way.
I mean, it looks like just it's oscillating the coil with the stereo signal, and the transistor is allowing the power from the stereo signal to pass.
Okay, you see that?
Yeah, that's better. Okay, so the positive goes in, and see where the positive touches that coil, it looks all kind of messy and hairy. I can't understand what that is at all. I mean, it looks
well, I'm
like,
trying to figure out what's going to the emitter to the coil. Is that like there's a third wire there? I'm trying to figure out which one's.
Well, from what I remember, you said that Gerald was using that transistor to protect the stereo from the flyback.
Mm-hmm. So I'm trying to figure out. So I only have a positive and negative in my coil that's hooked up to the stereo. How would I hook this up if I only have 2 lines coming out of the coil instead of 3? That's what I'd like to know.
Well, because I don't know. I'm not familiar with this circuit. I'm not going to say that I know that it works or doesn't work because I've never replicated it. And I can't really tell what it's supposed to be doing. I see the diode. It looks to me like it's facing the wrong way, though. Into the coil because the positive is going in one end of the coil. I don't know if that's one wrapping or 2 wrappings.
No, I think the diodes. I think the diode's in the right place because it's preventing the energy.
Yeah, the coil is the mystery here. I don't know how many ends that coil has, and I see that
yeah, maybe his coil has multiple channels. Like mine only has the 2 channels, but
I see the emitter is connecting to one point of the coil, and the looks like that coil has 3 ends.
That's what I'm saying. I need to know where the third one, because the third one looks like it's connecting to the emitter, but my coil only has a positive and negative.
Did he tap off the center tap the coil and create a third
Oh, maybe that's the pickup,
I don't know. You
the
got to ask
pickup coil
Gerald.
that he
This
uses.
is
I don't
this is
know.
Gerald's design, so he knows what he's doing. What's that thing on the right there with the red? Oh, that red.
Yeah, that's the direction of the current flow.
From the
So you see the
stereo?
transistor here and the current. No, it's the circuit, the protection circuit. So it's preventing the energy from going back
Oh,
into
this
the
looks
stereo.
overcomplicated. If you're protecting that stereo like this, I mean, yeah, go ahead, try that. But if you want to be simple, just get that NE-2 bulb and put it across the plus and minus of your speaker output. And any high voltage that goes towards that plus and minus of your speaker output will light up that bulb.
Oh,
And
before the junction for the coil, you're saying like right here.
the
Basically.
speaker has a plus and minus output for the speakers, right? The plus and
Mhm.
the red and the black. Put the NE-2 bulb in there.
Yeah, right there. Yeah, and
Yeah.
then connect the coil.
And then
to
connect the
light.
coil, right, the same points. And then when that coil flies back, if it goes to that speaker terminal, it will go across that bulb instead of across the speaker terminal, which is connected to the stereo, which will.
So I'm gonna try this, but I'm gonna leave out that third wire that goes to the emitter. I'm just gonna ignore it and see if it, even powers
So
up.
anything, basically look at it like this. Anything over 100 volts will go through the bulb. Anything under 100 volts will not go through the bulb. So as soon as the spike happens, it's going to be over 100 volts. And if it makes it to your stereo, it will go through the stereo and damage it. But if that bulb is across the terminals at the same junction where the stereo is feeding the system, it will go through the bulb because the bulb will accept anything over 100 volts. And it will read that high voltage and take it.
See how thick this boy is? It's a thick boy.
It's what Bedini uses for the SG circuit to protect his transistor, the 2N3055.
Sorry, let me
He
change
uses
this
that
so I
neon
can
bulb.
keep an eye on chat. I've been neglecting you, chat. I'm sorry.
You got to get
Nathan also suggested putting a diode on the positive supply of the coil. Yeah, I tried putting a diode on the positive side, Ian, but it didn't seem to. I don't know. The signal was maybe distorting too much or something because it didn't seem to do much. Maybe I had the wrong diode on. It's possible. But the thing is, like the signal needs to be the exact signal that I get out of the stereo amp. And the more components that I hook up on the positive side, the more I risk distorting that signal, if that makes any sense. But this is a circuit we can hook up on the negative side that should work for us in theory. Hopefully. I don't know. If anything, it's just fun to try. Oh, Lulu's here. I didn't even know Lulu was here. Hey, Lulu.
Hey, Lulu.
I don't know. Did she want me to add her to the stage? Were you able to add yourself to the stage, Mike?
No, I think you did. Are you using Streamlabs?
No, I'm using StreamYard right now.
Yeah, it let me in.
There we go. It didn't, yeah, it wouldn't let you in?
No, I was just hanging out in the back, just listening to you guys.
Oh, okay. I wanted to make sure you weren't like stuck down there, like, and you couldn't add yourself to the stage.
No, I couldn't add myself to the stage.
Victor.
Oh, you
I could just, yeah, I could just converse through chat. The comments or the comment section, I think. Hold on. No, the chat section. But
I didn't know that. I'm sorry. I didn't even see you there. I have the
it's all right.
Yeah, I have this set up so the screen for StreamYard was on the other monitor and I couldn't see it.
No worries, man. It's all right. I'm listening. I had a question. Could you put another circuit on the breadboard? Like, could you add more than one circuit, or does it have to be one at a time?
No, I've actually done multiple circuits on, like, I had the Bedini circuit on one breadboard and one half, and on the other half I actually messed around with another circuit I was trying out. Yeah, you can definitely do more. It's just, don't confuse yourself.
Yeah, I just wanted to know what the function of the breadboard was. Like how, like it closed off a loop. But I didn't
So
know if it was to closing one loop off just one at a time, or could you do it on multiple circuits? Like, for example, what you had it
Oh yeah, the
through
breadboard.
through the receiver and through the transmitter. Well, let's say if you put another coil or another circuit, I'm sorry, and attach it to another receiver, another transmitter, would it like would it
So
like
that
conflict? Yeah.
breadboard there, you see the left and right sides, how they're less
Yes.
holes. That's where
Yes.
you would put the your power supply. So that breadboard can handle. Well, you typically people put the power rail, the plus and minus on
yeah,
that
so the
side.
power rail, anything you connect to this vertically will be on the same power line. But
Right.
these
You know why
little
I'm asking
these
this? Because
A
it would
through
be so
D is
cool to conduct different mediums of experiments with one base to see the difference of measurements,
yeah. Yeah, I could put a
Yeah.
reference circuit and the output circuit on the same breadboard technically.
Yeah.
But the thing is, these little that you see A, B, C, D, and E, those rows,
Yes.
those connect horizontally, not like the power rails which connect vertically. So if you
Okay.
have one
Right.
in the first row here at the top, A, that's going to connect to E, right? It's not going to be vertical like the power rail.
Okay.
So
Right.
you can
All
imagine
the
it's
ones
just a
this
metal
way are
bar
the
going
same
across.
connections, so you can connect multiple things to the same bus. They call it bus lines.
Yeah, bus line, that's what it is.
Each bus is like one piece of metal, so a bunch of things can connect there on that same bus line.
That
And then you
reminds
have
me of
another
like
piece of metal.
computer configurations, like network configuration. Also, they in network configuration, there's something called like a bus line. Also,
Yeah.
for the different nodes of you know
Yep.
network. Okay. All right. Thank you.
Or they call it rails. Positive rail, negative rail, positive bus, negative bus. You can call it either or. They have terms for it. These things. It's just a terminology.
You
But
guys
it's one
continue. I'm
connection point.
listening.
So we got the 270 ohms hooked up to the base of the transistor. Let's start with that because that's going to be, I only have 220 ohm resistors and 10 ohm resistors. So we're going to combine them.
Mike, you were talking about like, is it the same thing, that neon bulb that takes 120 volts and acts like a protector for the voltage, because it could absorb,
Right.
a huge amount of voltage, so it acts as a protector for the circuit, so it doesn't,
Right.
okay.
It will not, if your circuit's running, if you're running your circuit with anything under 100 volts, none of that voltage is going to go through that neon. But as soon as the circuit surges and creates a high voltage surge, then the neon, it hears that because it needs over 100 volts to
So it's
let
like an
anything.
indicator that, hey, we're at the 100 mark,
Right,
voltage.
exactly.
Okay.
Bedini used it to protect his transistor, and so that when you disconnect the charge battery, that light will light up until you hook up another battery. So, and it also, just in case, you really don't want to have that light go off at any point without a load across it absorbing that flyback. Otherwise, that flyback is going to, go somewhere else and damage something else. And the only sensitive component in the Bedini circuit is the transistor. The diode is not really sensitive to being damaged by the flyback. It's usually, microcircuitry and switches that are harmed by the flyback.
So the transistors have three functions from what I understand. They can act as switches, amplifiers, and diodes.
Some of them contradict. That's funny.
Mm-hmm.
Well, a single transistor will step up. You can do what's called a Darlington array and increase your voltage, amplify your voltage, but okay, but keep in mind Ohm's law. When your voltage goes up, your current goes down, and and your resistance goes down, or no, up. Sorry, I remember this one. Ohm's wheel. It's a very handy one. I tried to find the wheel that showed the arrows.
All right, and that's connected to the base. Oh, I need some jumper cables. Be right back.
Yeah. Voltage goes up, current goes down, resistance.
All right. Ooh, this is a nice turquoise colored one. So as I've said before, the 13009 transistor that we're using from left to right goes base, collector, and emitter. So we're going to connect the resistors we have in series to the base of the transistor, like so. Let me turn this off so you guys can get a good view of it. So here we have our 220 ohm resistor and then 4 10 ohm resistors. Oh, I'm missing one. I think I need one more. Give me 1 second. Yep, I'm missing one. So we need 270. And then what we're going to do is we're going to hook up the diode. And the diode that I'm using is a 10A10 diode. It's a fat boy. And it is rated for 10 amps and 1000 volts. Dang, boy, she thick.
What happened?
Oh, nothing. I'm just excited about using this fat diode right here. It's so big. I'm weird.
They'll
I
block
like these
more, right?
components. Yeah, I like these components. They look neat. They look sleek. Like the capacitors, I like collecting different kinds of capacitors because you have all sorts of kinds of capacitors. They look neat. They're fun. This one's a little hard to mess with though because the gauge of the wire is real thick. I wonder if I can even plug this into the breadboard here. Oh, just barely. All right, so we're going to plug the negative end of the diode into the other end of the resistor set we have. There we go. And
Yeah, you have Mike from Faraday in the chat.
Oh, Mike from Faraday in the chat. Hey, how you doing, Mike? What's going on? Yeah, I sent everybody an invite. Nathan stopped by. Hopefully he comes back and hangs out with us a little more. I know he gets busy with his family on the weekends though. And Victor, I do believe I sent you and Ian an invite. If you didn't get the invite, let me know. I might have sent it to the wrong email address if that's the case. MJE 13009 is a NPN 400 volt 12 amp. If it's taking that sort of power, then you'll likely need a high wattage resistor. I think 15 watt. They're bigger ceramic resistors. So I'm going to need a big resistor, Ian said. I mean, this is the protection circuit. There's no, the protection circuit here says 4 ohms. I'm not really sure how to rectify that with 15 watt big ceramic resistor, or if you're talking about something else, Ian, if you could clarify though. Oh, okay, cool. Yeah, I just want to make sure nobody gets missed. I try to send an invite to everybody. Oh man. Oh, there's Mike.
Hey,
Hey, how you doing?
good. How are you?
I'm good. Oh wow, this thing can barely fit into this
Mike.
breadboard.
Oh my God, I just realized how bad my eyes are. I gotta wear my glasses more and more now.
Are you still using the cell phone?
Yeah,
That's why.
worst thing ever.
Yeah, it strains your eyes. I know that.
Well, I've been doing a lot of work today, rearranging all my stuff here. Let's see it. That's what I did.
Okay, so this is it. I believe that's it. Except for, oh, we need to hook up the 10 ohm resistor on the emitter side, and that's it.
I
Okay.
don't know if I've shown you this before, Ben. It's my the large Renegade.
Oh yeah, is that the 3D printer? No, that's not the 3D printer. What is that?
No, that's the big Renegade, the 100-pound one. The Adams motor generator.
Oh, it's
Pulse
a generator.
The
Yeah, it's a
solid
pulse
state.
motor.
Oh yeah, I got
No,
it's got
no,
the Faraday
no.
Reese on the corner. I like that.
Yeah, my wife made all the decals for me.
It's sleek looking. That's
Yeah,
sleek looking. It's a pulse
It's in
generator.
it's like an Adams motor. It's a Renegade Adams motor, modified, 12-inch wheel, 4 coils. One coil's the trigger, and then 3 pickup coils. It runs on 50 volts DC, and yeah, it's a powerhouse. I got actually. Let me move this out of the way here.
Mike, you could make this into like a camping piece.
So
Like if somebody goes
they
camping,
got 4
like, you could sell
motorcycle.
that for them.
Yeah, there's 4 motorcycle batteries hooked up in series. So that gives me about 49 and change volts. And that's what powers it. But those batteries don't.
There's a good chunk of change there.
Well, yeah, like the whole box itself weighs about 100 pounds.
Wow.
It's heavy duty. With the batteries, yeah, it's a server case, right, for computer systems.
Yeah, that's what I was gonna say. At least you know it's built well.
Yeah, it's got a locked door. Locked door. It's got blue LED lights on the inside.
Ooh.
Yeah, it's really cool. So
that's
I'm gonna
what I like to see.
Yeah, I'm gonna fire it up again this week. I gotta get it going. I haven't had it running in a while because I've been busy with other projects. So here's my my case with all my gear. Like the case I got here is 7 feet tall.
Looks well organized, at least.
Yeah, I worked on it all day to reorganize everything, and
I know you get in a hurry and you get, a lot on your schedule, and all of a sudden your well-organized lab is disorganized and you need to take time. And
you know what I want to show you? I was talking about my hold on, bear with me here for a second. I wanted to show you my my coil winding machine. Just bear with me 1 second. I have to put
you
the
have
phone.
A coil winding machine?
Yeah, I built it.
That sounds cool.
That sounds amazing. Yeah. Oh, while he's looking for that, I did complete the circuit here. So as you can see, what I did was I set it up so the input or the plus and the minus of the coil just go right into the one jumper cable here, and then the negative goes into here.
All right, here it is. So I got a motor. There's the DC motor controller, PWM. I got a foot pedal so I can stop it. You put your coils on here. I also got a counter, proximity sensor counter, electronic counting, so you can count how many wines you do. And I built this for like less than $60.
Oh wow, look at that.
So you mount your coil here, tighten it up with the bolts. You have full control PWM. Hook this up to the battery.
And then the battery.
And you got the foot pedal. You put that on the floor so you can stop it when you want. And you can
the foot pedal is hooked up to what? The motor?
to the PWM. So if I want to stop it, say something got screwed up or whatever, it's like a kill switch.
Nice.
Right. And then the 2 wires hook up to a 12-volt battery. The foot pedal goes on the floor, and you control your RPM here.
I think if I'm dealing with high voltage from now on, it would be best to build in a kill switch in all my circuits.
Yeah.
Yeah. No,
But anyways,
cool.
like stuff like this, and this is all 3D printed, the mounting, and I got the some nice bearings in there, threaded rod. Yeah, you can make stuff like this to make your job a lot easier, especially if you're into coil making, motor coils and stuff like that. This is what you need. And I'm telling you, this saves you a lot of headaches, and your coils turn out so much nicer.
Yeah, you won't have kinks in them.
Yeah,
exactly. All your wines are a lot more uniform.
Perfect. Yeah, like they will be more manufactured than back engineered.
Yeah. And I just bought a mini saw this week. I don't know if you want to see that.
Yeah, show us anything you want to present. I'm down. I'm gonna take a break from this for a second, anyways, and so.
Let me grab this.
What is it?
This might be done.
It's a mini table saw. So if you live like in an apartment like I do, you don't have that much room to work with, right?
I've seen those. They're cute. Yeah.
Yeah, they're actually really neat, and they can cut acrylic, wood, some metal. So yeah, it's
like a small indoor project.
Oh, I think I get the circuit now, guys. It's the same wire. Look, I think this positive wire is supposed to be the same that's going into the diode that's up here on the notch. So I confused it. I thought it was 3 different wires. I feel silly.
So there's your switch. Comes with the power supply. It's $100.
Oh, neat. That's a
It's
little one.
It's really cute. It's like
that's perfect for the Ninny Lab, dude. That'll be perfect for me.
Compared to my hand, there's my hand, so I can kind of get the idea.
Yeah, it's perfect size for small. Like you don't need a contractor saw. For things that
it's quiet too, right? Doesn't make much noise, so you don't piss off your neighbors.
Yeah, you can make your crafty wood stuff pretty easy.
Yeah, wood. Yeah, it cuts wood. It cuts acrylic. Some aluminum, thin aluminum. It'll cut
PVC.
Yeah, stuff like that. And yeah, it's just convenient, right? And it's also got the protractor, and you can do angle cuts. And this slides back and forth, so you can adjust your width of your cut, or you could take it off completely. So, yeah, little stuff.
Does it have a blade sensor? If you get too close? Okay.
No, it's not that advanced. Pretty basic. But definitely handy to have if you need to do little cuts and you don't have room, or you don't want to make a heck of a lot of noise, right? This thing's virtually just makes a hum.
So Ian said it is 3 connections to the coil. Positive supply goes to the center tap of the bifilar coil, and the 2 outer ends are from the diode and the emitter. Oh, so my coil only has the positive and negative. It doesn't have the 3rd tap.
Oh, center tap on the coil?
Yeah, so I'm trying to figure out how I hook this up without the center one.
Well,
the center's just going to the emitter, right?
Well, the center technically is your ground. It can be your ground, or it doesn't go to anything. Just tie the two ends of each set together, like you would, like say, like a series circuit, right? Because I was working with this type of setup when I was working with the Don Smith generator, and he used a lot of center tap type setups with his coils. So he used to ground it with a very large high voltage diode to ground, earth ground. So the way he used to do it, the first coil would be clockwise, say 20 turns. And then at the center tap, he adds the second coil, which will be now 20 winds counterclockwise. All right. So on the first coil, you got your volts. And on the second coil going counterclockwise is your current. And that's how he was able to get so much current out of those coils, is by switching the direction of the winding.
Yeah, like I think Mike did mention that so the emitter one is the center tap, and I could just ignore that then.
You can just bypass it. You know, the first connector of the first coil would be positive, and then the second connection of the second coil would be your negative, and then the two in the middle just be joined together. You could do it like that, right?
Well, so this is the way my coil has. I has two channels. Each channel has a positive and a negative, and the two channels are not connected. So we're just focusing on channel A in the circuit. So there's just positive and negative. So what I'm thinking is just ignore because the emitter is already hooked up to the resistor and the stereo on the negative. The base is hooked up to the positive, then the stereo. I believe that's it. Just ignore the center tap, right?
Yeah, the center tap you can just join together and leave it alone, right?
Yeah. Well, I don't have a center tap, so I'm not going to join anything. I just don't put it in it. Yeah. Okay. Yeah. Okay. So that should work then. Okay. Thanks. Thank you, Ian, for clarifying that. I really appreciate that, man. And for you, Mike, as well.
Yeah, it can be a little confusing at first. I was confused. Don't worry.
Both Mikes. Mike helped me out, and then Nathan dropped by briefly and helped me out a lot. We found a really cool waveform when Nathan told us to drop it down to 50 volts and then slowly drop it down from there. We did just that. And when we hit 20, it had this really weird waveform. I've never seen anything like it. It was really cool.
How can you describe what you saw?
I could see if I can bring it up. Yeah, I could take a screenshot real quick if I tab out. Give me 1 second. Yeah, it was really neat. Actually, do we have it? Yeah, I might have disconnected it in the Chrome. Yeah, I can take a quick screenshot. Give me 1 second. I almost found it.
God, my eyes are going. I'm almost tempted to go to the car and get my reading glasses. I guess I'm
go ahead.
You know, like a HDMI connection to
Yeah,
your phone, you could like play the screen on your TV.
Oh, I know. I already have that. Yeah, I've got I think it's a 36-inch TV or something, or 27-inch or something like that. And it's got all the. I can hook it right up to that and stream through that if I wanted to. Yeah.
Right.
Yeah, that way you might be, your eyes won't stress too much on a small
screen. Yeah, and also I used to get these tinted things for my glasses as well, like yellow tint.
Yeah.
Blocks out. Makes it easier on the eyes. I did find that, by the way. I'm going to put it in I'm just temporarily putting them in this research guide I put together just so you guys can see real easy. Let me scroll down. So you see that? I don't know. It's just we were trying real hard to get all sorts of, anything to show up on the oscilloscope. And we finally got it hooked up where we would mess with anything like the hertz. We would change it, just anywhere, put it up or down, and it would just have this small spike. And then, Nathan comes in, he's like, no, you got to drop it to 50 and then slowly reduce it. And we did that. And look at this. I thought that was really neat.
Yeah. Well, it depends on the coil that you're using, right?
Mm-hmm.
Okay. Where's my chinchilla's going cuckoo here? Mr. Sushi.
You got a chinchilla?
Yeah. Mr. Sushi.
Mr. Sushi. That's awesome.
Yeah, they got a pretty long lifespan. They can live over 20 years.
Oh, that's nice. Yeah, I don't.
They're like cats, right?
Oh, they live a lot longer.
Oh wow.
Oh yeah, way longer. A cat will live maybe 14 years or less.
Are they like the rabbit family? Kind of?
Like a miniature kangaroo. Hold on, I'll put Mr. Sushi on. Sushi the star. Sushi, come here.
Or hamsters, right? Or no?
No, it's way bigger.
They're more complex mammal.
There you are, Sushi. What are you doing?
Oh my god, that's cute.
Like a miniature kangaroo.
Yeah. Or like I don't know if a not a panda bear, a koala.
No,
Koala.
not even. Koalas are small. This guy's fast. Sushi, what are you doing? Come here. Sushi.
Oh, he's so cute.
Yeah, he's got really big ears.
Should have called him Dumbo.
Do you put him outside the cage, or is it always?
Yeah, she'll bring him into the bathroom and let him run around. Yeah, he's got a little attitude, this guy. They're nocturnal, so they're awake during the night, sleep during the day.
You should build a tube for him to travel through in every room of your house.
Well, we live in an apartment, so it's, can't really.
Okay, never mind.
Well, he's got like a 3-story condo happening here, so we got a bigger cage for him. And
no, I thought about doing that with like hamsters, but that's a terrible idea. They'll poop everywhere.
No, terrible idea. They can escape and you lose them.
Yeah.
And then weeks later,
they
you
chew-
find them like somewhere where the kids trapped them and they forgot that they
Yeah.
were there.
They'll chew
Oh,
through
wow.
pretty much anything.
Yeah.
Literally.
that too. Yeah, they chew.
Oh, yeah.
Oh, wow.
Oh, yeah. They chew like everything.
Well, he's a little cutie. That's for sure.
Yeah, he's cute.
There's one time I bought my kids 2 hamsters and one escaped. Man, I found it behind like the sink, the kitchen sink. It has like a trash can underneath behind.
Oh,
and
yeah.
I had that, and the place would smell. The thing died in there, and I couldn't for the love of me figure out where that smell was coming from. And then eventually, I don't know. I needed to get something from underneath there, and I see this blob of fur, giant blob of fur. Yeah, it was the, escaped hamster. So yeah.
So I'm gonna take a quick break. I don't know if there's anything that you guys wanted to talk about, but if not, I'll just put on some music while I'm gone for a few minutes.
Mike, did you finish the 3D printing the other side of the battery casing?
Yeah, I did actually. Here, I'll show you.
Oh yeah, the case, the green case.
Well, yeah, because like you said, it would take an hour and a half to.
Yeah,
cool.
each total, both sides, about 3.5 hours.
That's
Looks like
thin.
it fits together nice.
Yeah, that's.
Oh yeah, the tolerance
very
is
thin.
very, very good. Yeah.
Yeah, you didn't have to adjust that or nothing. Just you printed it
No.
and fit.
Well, I'm very good with AutoCAD Fusion. I'm a pro with that thing. I've been using it for about 10 years. So I know how to use Fusion really well. And makes parts fit extremely close tolerances. So
The work of a true mechanical engineer.
You know, I was thinking yesterday about the filament you were talking about. Like you needed to get filament for the 3D printer. What if you use that, like the weed whacker plastic foil?
it's similar to that, but this one's called polylactic acid, or PLA they call it. It's kind of your base, regular base material.
Yeah.
It's a cornstarch, so it's biodegradable. It's pretty hard. Like it's tough. Like if you print a thick layer,
Yeah.
the density is thick. It's tough, but there are materials out there that are a lot more tough than this. They got carbon
But
fiber.
it's waterproof though. It's waterproof.
Oh yeah,
so
yeah.
that's the important thing,
There's CPU, HEP. They got a whole whack of materials now. Carbon fiber. Yeah, they have some of the abrasive stuff, so you have to use special nozzles when you're printing because they're a lot more abrasive. So yeah, there's a lot of, like, the technology's gotten so much better since, I started getting into 3D printing around 2012. So I've been at it for a while, well over 10 years. So yeah, the technology is a lot better. The materials are getting better and better and stronger and stronger. And,
Have you ever seen this like this thing? It's like a kid's toy. It's a pen, but it has filament.
yeah,
You
it's
could
3D
yeah,
pen. Yeah, 3D pen.
yeah,
Yeah,
that
yeah. It
sounds quite
uses the same kind of filament.
Yeah.
It's just it's in a pen form, right?
Yeah.
So
It's easy, like for like quick demonstration of something. If somebody wants to, and you don't have to use tape or glue
yeah.
or anything to draw up a 3D
Mhm.
model for anybody. That's like if you want to show somebody, like it's such an easy tool to use. It doesn't take time. It's like just immediate.
Yeah. Yep. So yeah, it's handy. I come up with a part I need or whatever. I
Yeah.
do it up in Fusion, and then in a matter of a few minutes, I'll have it on the printer, and it's printing your part. And depending how long it takes, maybe an hour down the, in an hour, you have a complete part ready to go that you can use.
This is the technology of the future where everybody has on hand
The
to fix
replicator.
things. Yeah, like to fix different things in your environment. Not necessarily you would have to it will also like reduce plastic waste if you think about it, instead of
Yeah.
like you
And,
ever
all
chucking
this
out
material,
something.
like this material too, is recyclable. So you can throw it in your recycle bin and it's fully recyclable. So
Yeah, like for example, like girls, if something is cracked or a little broken, we see it as ugly and that's it. It goes into the garbage can, even if it works. But if it has a crack
Yep.
in it, like it has a, and like something in it, although it could be mechanically works perfectly or electronically, but just the aesthetics of it,
Yep.
this is how. Yeah. So now, like with this, you can fix things, which then extend the life of objects.
Yeah. Well, everything's disposable now, right? That's the
Yes.
problem. Everything's disposable. Yeah.
It's a rapid pace commercial system of like constantly needing to.
Well,
It's a recyclable system. It's a fast recycle.
Perfect example would be a cell phone, right? You have a cell phone, you pay it off in 2 years, and the next thing they say to you, oh, upgrade to the next model, which everybody does. Meanwhile, there's nothing wrong with the phone. You could keep the phone, it's paid off, but everybody wants to upgrade. They want to upgrade. So whatever you have is disposable,
Yeah, no, they tell you this. If you look on your phone, on your certificate of trust, each cell phone has that. It'll tell you, oh, this will be supported till this date. After this date, we will no longer support your device.
Yeah, right.
But how nobody understands how important this is. For example, I put my Coinbase account on my phone, right?
Yeah.
And when it was in the phase of trusted certificate, but when it expired, when you need to do an update to your phone, it says you're like there's no more updates that support this old phone. So whatever cryptocurrency you had on a cell phone device, guess what happens to it? It gets lost. Call Coinbase to authenticate your account. They want the phone that you originally downloaded the application, but the phone cannot be updated. So
Right.
therefore, you cannot receive an authentication code to, your like two-factor authentication, because there's no more
Right.
updates for that phone. So what
Right.
happens? You lose every. This is exactly what happens. So they force you, if you want to keep valuable data such as digital money, they
Right.
want you to change devices, and you only have that window of time when
Yeah.
it's still under the trust certificate to be able to do the change.
What a crock.
Yeah. And I mean, I went through this. They still send me emails from Coinbase. My question to them is like, how are you sending me email, but you won't authenticate the new phone? You want the
Yeah.
authentication to come. Like, then
That's
what is that
absolutely
email that you
tedious.
have, on file? If I'm receiving it and I'm able to send you a, response through that email, you should be able to authenticate their phone. They couldn't do it. Like,
Mhm.
yeah, I mean, it's not a big deal of money that I had. It was more of research money, meaning I learned the cryptocurrency program, and they rewarded me by giving me a little bit of it. So I accumulated it, and I started transacting with whatever I learned I earned. And so honestly, I didn't put a penny out of my pocket. It was just learning how their blockchain system works. And I learned how to convert from one cryptocurrency to another based on whatever the numbers out there, and the time, when something came on their like news blog, I knew it was going to go up, and just different factors. Yeah, but I lost it all. And it was when I lost it, it's when I called my bank, and I told them I wanted to be able to convert from from Coinbase into my account, but I want you to track the data all the way
Right.
to the Treasury Department, because that is going to have an equivalence from the Treasury Department that needs to be printed as real money. So there is
Right.
a code that's going to be transacted from the digital currency to the bank. The bank sends a
Right.
request to the Treasury Department to validate this as real money. The
I trust
Treasury
Kraken.
Department has to issue a bill, like a monetary bill that follows the conversion of this specific transaction code
Try.
that
Yeah.
gives it value. So
I
I
don't know.
said, I want
Coinbase is
that
fishy.
$100. And then my phone went shut down. Everything stopped working. The bank
They
started
all.
giving me a hard time. Yeah, believe it
You
or
ever
not.
use Kraken? Kraken?
No.
Oh, they worked for me. I used them once to convert crypto to cash successfully. Kraken, Kraken. They're an exchange, like Coinbase. They're very well known. Anyway, Coinbase,
Mike,
I
Mike,
think,
it
charges too much.
wasn't about the value. It was about the process. I
Yeah, you
wanted
lost
to
your
know
crypto
how.
through Coinbase because your phone
Okay,
thing, right?
again, it wasn't a big deal, but I wanted to follow the data process. How does data transact into monetary value on a government system? From
Oh, they use a
banking.
ledger. That's called a ledger.
Okay, whatever that ledger, whatever the code that they converted my digital currency to real currency, I wanted that one when they printed it, because that particular one is allocated to this code.
The ledger's on the
I
blockchain of whatever
no,
crypto.
I think you missed my point. You missed my point. Is when I wanted to convert my money through the banking system to make it into
Oh,
real
that's
US
a stable
dollars.
coin. You have to convert your crypto to a
Yeah,
stable
I had
coin. Like
Bitcoin.
Well,
Yeah, I converted them
the
all
main
to
point
Bitcoin.
is
Yes.
Bitcoin is
there's
not a stable coin.
the main point is they're forcing people to upgrade to their phones, new phones. Like by eliminating features, like I've had that where you have to upgrade or you don't get access to a
Yep.
feature. So, and okay, no, I wanted to show you guys this. Elijah just sent me this. It's another Bedini diagram. Just
Yeah, that's
something,
one of the original ones that I've seen.
yeah, it's
That's been
basically
out for a long time.
the same thing that Mike has shown us. Only it's like you said, it's original. It's got all the original captions and all that. So I just wanted to take a look at that, and I'm gonna set up my camera for the lab in a minute so I can show you guys something interesting that I found yesterday.
Tether, USDT is a stable coin. USDC is a stable coin. DAI is a stable coin. You have to convert your crypto to any one of those before you can convert it to US dollars. Once you're into a stable coin, then you can convert to US
Yeah, at
dollars.
that time, banks were accepting the conversion of Bitcoin. So I
Oh,
converted
yeah, that's
everything into
fishy.
Bitcoin.
How
Yeah,
long ago was this?
about 2 years ago, 2 and some.
Oh, yeah, that's Bitcoin is not a
I
stable coin,
still
though.
have that cell phone where the Coinbase application was originally downloaded on. So somewhere in that, in that phone, the data for those crypto blocks are in there. Get it? But I
Yeah.
cannot extract them unless my phone is up to date with the ISO of whatever right now
God.
that they get it.
What a
Oh,
So
nightmare.
it is.
jeez.
But it's a way for them
And
to
you got to wait for
control.
Coinbase to upgrade or whatever.
Okay, well, it doesn't matter. Coinbase already upgraded, but they have in their system my old MEID
Well, can you
number,
get
and
into your phone and read the private key manually from there?
I
You're
don't
good
know
to
how to
go.
do that. I don't know how to do that.
You have to copy paste the private key to something like a text
Yeah,
pad, and then
but I
copy it
could
from the
I
phone
could
to a
have
USB stick
many.
or something.
I understand, but I could have many private keys and through
Copy
Coinbase,
them
the
all.
application. Yeah, but the application cannot get into it anymore. Like you click on the app, the
Oh,
app needs to be updated. You can't update the
yeah.
app because you need to update the ISO before you
Jeez.
update that.
Yeah.
Yeah, it's like yeah,
I
but
can't
it's a
say that I
learning
haven't had
process.
pitfalls with crypto myself. It's a new emerging system, and
I
I
don't know.
wouldn't
For
put
me,
all your stuff in there.
all I wanted to was to how do you take something in numbers in the in the
A
digital
private key is
world?
what you want to look out for and get that as soon as you can.
I don't
That's the
know.
most important thing. Any seed phrases or whatever that you can get
I
out
don't
of
know
it.
now if it's in my like
It could be a
very
seed phrase
deep
or other.
down.
The Coinbase could be storing the data for your crypto in a seed phrase.
Yeah, but they won't give it to me because they want to authenticate my identity through the device that I
Oh, they have your seed phrase, don't they?
downloaded the application on. I'm telling you,
That's funny. They shouldn't be even having your seed phrase. They should not even have the ability to give you it.
I don't know.
If it's truly crypto, because you're not supposed to, there's no
I'll do
middleman
this
in
one
crypto.
day.
Nobody has your
Like
password.
not on YouTube, but like if you guys want to help me, like, well, bring out the phone, charge it up, turn it on, and let's see what the
that's the
prompts are
thing to
to
worry about with
extract
crypto.
those.
There is nobody in the middle to help you when you forget your password.
I didn't forget my password. It would not take the password because the application
Right.
needed to be updated.
That could be upsetting
And
too.
the application cannot be updated unless the whole ISO is updated.
What's the name
Because
of the app on the phone? You can't install the same app
Coinbase,
on a PC?
I tried. It does not recognize the same. It'll tell me, we're going to send you an authentication email to your original device.
Oh, it doesn't recognize the device, right? Mm-hmm.
Yeah.
Because of the certificate. There's a certificate on the phone. You have to transfer the certificate from the phone to the PC.
No, they do not support this certificate anymore because the iPhone model is old. You understand? So they're basically telling me that our IT department does not want to maintain an old version of an iPhone anymore. We're not going to allocate any
Yeah,
more
it sounds
server
like the
space
only
to it.
way is to update the phone, get in there with your login and password, and then
You
then
can't.
get
It's an
the
old
seed
model.
phrase.
It's an old model. Let's say if it was an iPhone 7.
Well, then if you don't have
There's
much
no
in there, then
more.
don't worry about it.
Well,
Right.
it's about the concept. It's not about how much is in there. It's just the concept. It's a principle
Right.
thing. It's like a principle of order of operations, of timestamps, of things. Because when they do iCloud, they import your photos. That's another thing.
The best way to store
They
your seed
change the
phrase or
date
your
on the events on let's say if the image does not have any identifying marks such as a date on it, or a background of a TV, or any number that, if the AI can identify the date, it'll put the right date. But if the AI cannot identify the date by the image, it could put it randomly anywhere it wants to fill, like a space that it doesn't want to replicate or doesn't want on its servers. It might be better if I explain, like, sometimes explaining things is by visual is way better than just talking about it. You get it? Like if you were, I could show you step by step, your jaw would drop. You'd be like, what the hell?
The best thing to do is to clone the image on the phone and back it up. The image of the phone, the phone's hard drive, wherever it stores all the data for that phone. Is it on a RAM chip? And that's hard to do. And once you get the image off the phone onto the hard drive, then you should be able to load that image virtually as a phone using a phone simulator on a PC.
Okay, Mike, I tried a lot. I tried almost
and the
everything you're talking
certificate
about.
wouldn't matter because it would be on that image and the image would still see it as the same device. And then you can update the phone virtually on a PC using a phone simulator to load a phone image, image of a phone OS.
I have no idea how to do any of what you just
There's simulators like that for video games too.
Like trick the system.
No, it's just simulator. What's the name of the phone?
iPhone.
Okay, you want to search for iPhone simulator for the PC. And then if you can find that, you want to copy the storage that is holding the image of the OS for that phone, which is somewhere on that phone. And how do you do that? I don't know. You have to plug into the phone somehow and use another app to back up
to make
phone's OS
a long story
as
short,
an image, as a picture,
I'm
not
going
as
back
a
to school for science information technology, and this is one of the
an
issues
ISO.
that
It's
I'm
called
going
an
to be
ISO.
presenting. I'm going to be presenting one of these issues. It's like, I'm pretty sure it's not just me that has this problem.
You want to make an ISO image of the phone and load that ISO into a virtual program to simulate that phone on a PC. Then you can upgrade the phone on the PC using the virtual simulator. And the certificate will be on the image that you move to the PC, so it will recognize it as the same device. And you won't have to re-authenticate another device, is what I'm saying. Technically. But that's if you take an image of the phone's OS, a picture of it. They call it an image, like a ghost image, or a ISO is another term, ISO image. And there's ways to do that on phones with the USB cable plugged into the PC, and there's apps that can do that.
One day, maybe. I'll
That is, if you got enough value in crypto on that phone, that's the first thing I would do.
No, it have maybe $100 in there, but it's not the
Oh,
point
then
of
don't
how
worry
much.
about it.
No, it's not. It's not. Okay, you still missed my point on all what I said.
No, I get your point.
point-
Believe me, people
my
are losing
point
money left
is-
and right through this issue that you're describing here. Believe me, you're not the only one. It's happening everywhere. Like people don't know how to store their private keys and stuff.
I don't care about the loss. I don't care about the loss. I care about the loss of the data sequence, on how it should have went from one program, the conversion. This is what I wanted to do. Well, I waited till it was $100. Actually, it was 108. Why? Because if they're going to assume any fees or taxes or this on, the conversion should be no more than 8.25%. Because 8.25 is our legal fee for taxes on money. Get it? So if I'm going to, so I left in there enough for
phones are going to be obsolete soon, I think. I mean, these wireless carriers are going to be, getting stressed out because everybody's going to use internet instead of wireless. The wireless cell phone is going to be wireless internet, and then they're going to have to, get a monopoly on the wireless internet. But, you could do IP phones over the internet all day long. I mean, Magic Jack gets you a phone for $50 the whole year, and sometimes they give you 5 years for $50. and it works over the internet. It's an IP address converted to a telephone number. And you just, if you know how to use that, you plug into the internet and make phone calls. What do you need a wireless phone for? If there's wireless internet everywhere, what do you need a wireless phone for? You see what I'm saying? And wireless phones are like $50 a month, you know.
I understand what you're saying, but I think I was trying to make a different
I mean,
point.
the
But
highways,
your
the
point makes
roads,
sense
the
too.
wireless internet is pretty much everywhere except for like, you know, small state roads and stuff like that. There's not much internet out there. They still haven't put out the towers in those areas to provide internet. But you would rely on your cell phone to get internet in those smaller areas without so many people would rely on a different slower connection, was what I'm saying. And the phone might not work, might not be enough bandwidth, but enough bandwidth for, you know, texts and stuff like that. I don't know. Roaming, you know, remember roaming? You used to be able to roam globally on your phone, pay 50 cents a minute or whatever on a wireless. But, you know, $50 a month when you could pay $50 a year for an internet phone, you really don't, you know, I don't know. I just think wireless, I don't see it as, it's a good backup, you know. If you need to go somewhere where there's no connection other than the wireless, you know, 5G, what is it? What is the carrier now? I don't know. They have different signals, but it's not internet. It's not internet signal. It's a cell phone signal for dialing numbers. But the internet, the wireless internet
LTE?
is everywhere in any county or city or that you're in. So you can take a standard cell phone, not have any service for it whatsoever, turn on the Wi-Fi feature, and connect to the city's internet. And there you go. And you can install Magic Jack on your iPhone and get calls through the internet on the same phone.
Yeah, and then everything that you have on your phone becomes part of the public server
It's
because you
internet
run
phone.
yes, but because you ran your phone through a
It's
government
the same
server.
thing with the wireless carriers. They use the internet. They just resell you the same thing. They're using the internet protocol to do what they sell you wirelessly. It's just they can sell you the signals. I forget what it is, 900 megahertz, or I forget what the bands are called. But the cell phone bands that they're using now do not transmit internet connection to anything. They transmit connection to the cell phone networks that they own privately. And then from there, they can connect to the internet. And they do. And that's how they resell you the same internet phone line over a wireless signal to areas where there is no wireless coverage. Like, I guess it's not 3G and 4G. That's internet. And 5G is
It's a
internet.
relay. It picks up your signal and the relay transfers it to another node in the web.
Right. Towers with transmitting, you know, cell phones are like megahertz range. So the internet now is on the gigahertz. That, you know, when you're driving on the highway, that's gigahertz towers. Like 3G, 4G, and 5G, 3 gigahertz. But the cell phones are like 900 megahertz and just under a gigahertz. That's the cell phone
Because
signal
if
for
we're, if
like
we're
your cell
running on
phone now, you know.
5G, that would be 5, you know.
Well, 5G is carrying internet connection, not talk connection like your standard under 1G megahertz, under a gigahertz, like in the megahertz range, your standard 900 megahertz cell phone signal is not connecting you to any internet server. It's
So
connecting
you're
you to
telling
their
me the
private cell phone
1G
network.
gives you just a call signal, but
It's
not
their private
a
cell phone network where they purchased the rights from the FCC for 901 megahertz or whatever at a certain price per year, and they get to broadcast
well,
on that
then it works like a
privately
walkie-talkie.
and sell
Then it
you
works
the
as a
frequency
walkie-talkie is the same,
bandwidth.
concept. Walkie-talkie is a frequency that is a public frequency, but it's tuned to two different points that uses the same space. And but it doesn't have internet capabilities, but it has communication capabilities, just audio and transmitter,
Right, but
and
let me
then
tell you, without the internet, forget it. The internet is the World Wide Web. There's no better way to term it. It really is. You can get any book throughout, almost any book. I mean, not any book, but
I mean, you're giving me the pros of internet as if I don't agree with you, but I absolutely
so
do. But
yeah.
I'm trying to say, if
And not only
you
that,
want
it's
to,
better for communication too.
isolate different signals and not needing to use the other ones, such as maybe I want to just have a conversation audio and I don't care if the whole world is listening or not. You understand?
Well, that's a radio station. The one-way
Walkie-talkie is
transmission.
the same. The walkie-talkie is a radio to radio, if you really want to think about it.
Walkie-talkies, right? Where they're, they have channels people can broadcast
So
from
do
their own
radios.
walkie-talkie and be
So
part of
do
the radio
radios.
station.
So do radios.
Well, the FCC controls all the particular frequencies that you're allowed to transmit on. You can go ahead and do whatever you want. They're eventually going to find you, and they will shut you down because you didn't pay for it and you didn't register for that frequency. Even if nobody else did, and if nobody else did, you might get away with it longer, but eventually they're going to find you and just give you a fine. And I don't think it's going to be prison or anything like
Mike,
that.
how did we get from this to what I was telling you, how the trust certificates, on older cell phones
As long as you stay under
aren't
5 mile
supported
range, you're
anymore
fine. It's
by the
legal.
carriers. And so a lot of people lose very important information because the digital data did not convert into the new system. And a lot of people don't even know. They, especially the older generation, they think if the phone
Okay,
rings
guys.
and they can answer it, then it's okay. But they don't understand that, the timeline of their device has expired everywhere. Nobody wants to support that, saving that data anymore.
I have
No?
something interesting to present. Let me
Go for it.
change this real quick.
Yeah, but I have a
Okay.
theory about that. I'll tell you later, Lulu.
Okay, so I was messing around with a 12-volt power supply adapter I had lying around for, I don't know if you can see it in the background next to the workbench power supply. It's a little magnetic globe. It's a levitation globe lamp, and it had a little adapter, a 12-volt 1 amp adapter, or 1000 milliamps. So, and I know that in order to power both of these circuits, I was needing at least 1.5 to 1.85 amps, and a little over 12 volts. So, or I think we were right at 12 volts. So this is interesting because when I plug this adapter in, it should only be giving these circuits, like it's going into a little mini board stereo amp, and then it's going into the coil for the output. And then the second channel is going to the reference circuit. So this is all coming out of this little mini board plugged into this 12 volt 1 amp adapter. And when we put it at, say, 60 hertz, or anything outside that resonance range, it doesn't power up at all. Like you see it flash like it wants to, and then it's just not getting enough power. And you turn up the gain all the way and it's not doing anything. So this is very interesting because when I switch it to 1000, both of the circuits power up nicely, which means that this output circuit, the one channel, is drawing a lot less power. And the 1 amp is able to sustain this somehow. And it's very interesting, and I'm going to show you right now. Okay, so we're going to start at 1000 hertz. This is the resonance range at square waveform. And as you see, when the circuit's already powered on, the oscilloscope's on. As you see, as I turn up the gain, both of the circuits are going to power on. The coil is going to power on first, obviously, because that's actually taking in less power and putting out more than the circuit, the reference circuit, which is just hooked up to the board, nothing else. So this is just a proof, more evidence that something is going on with this coil that's increasing the efficiency dramatically. Now watch this. Oh, you see it? Nothing here yet. Turn it up a little bit more. Oh, this is on. Oh, you can see this is kind of on. So I turned it up a little bit more.
Fan? We're looking at
Yes.
the fan, right? Okay.
So this is hooked up to the coil. This is getting a lot more power on the output with the coil. This shouldn't be. This is 8 ohms of resistance hooked up compared to this, which is just hooked up to the board. Look at just a tiny bit of power coming out. No fan spinning, by the way. Okay. And I could turn it up a little more, and both units will spin. So that just kicked on. And you can hear this is pretty much at full RPM, which requires 9 volts, by the way. Let's turn this down a little bit. And we're going to switch it to 60 hertz. And watch this. You'll see that it tries to power up and it just craps out because there's not enough power. See, it just shut off. I'll turn it back down and turn it up again. Nothing. Absolutely incredible.
Tribulations.
And we're back at 1000 hertz. Changed it back. And we're back up. All of that 12 volt, 1 amp. Oh, I just lost my headphone battery. So bear with me, guys. But this is going. It's going strong. I'll leave it running here for a minute while I switch my battery.
What I'm saying is, once they start broadcasting internet wirelessly the same way they're broadcasting cellular signals for phone conversations, the cell phone companies are going to be super worried because everybody can just use the internet to do the same telephone connections without paying all that money. You know, you're talking a couple bucks a month for internet phone service. It's always been that cost, you know. They're ripping us off for years with these cell phones. You got a private network, wireless network in the frequency megahertz range that they purchased from the FCC, you know. So somebody like the same network, like let's say Verizon or whoever, they purchase a frequency in the gigahertz that works well for transmitting internet. That's good enough to do phone and video conversations. And that's the end of it. People don't need cell phones anymore. They don't need the lower band frequency that cell phone uses, is what I'm saying. And if they do, they're going to use it for internet protocol instead of whatever protocol they're using it for now. It's not internet. It's a different protocol of transmitting batches of data to convert them from analog to digital and then back from digital to analog.
The TCP.
TCP is not converting analog to digital. Well, it is. It doesn't do. It's internet protocol. Is what I'm saying. It's the only way to get on the internet is to use that protocol. So if you're using a wireless protocol and it's not TCP/IP wireless protocol and it's some other wireless protocol that the cell phones use, like the cell phone networks use for their private networks, which is not TCP/IP. It's something that they use an older method of doing audio with the wireless signals. But the protocol is how you send those signals, and the servers that hear them will recognize it.
So what protocol does cryptocurrency follow? Analog or internet?
Blockchain.
Which is what? Okay, which is what?
Which is a way of stacking data on a ledger that records
okay,
the
but what is the
financial
transmission medium?
transactions.
What is the transmission medium from one point to another? Let's say I sell you.
It's a ledger that stores all the financial transactions
works
ever
on
created.
what? That
On
works
that
what
blockchain.
network?
That blockchain creates a ledger.
But what is the medium of like, does it go through wires, or does it go through a satellite system
the
signal, or
blockchain,
does it go through a carrier signal? What does it use? What
the entire
protocol does it use?
blockchain is stored like bits of data on a node, on what they call nodes, and there's more than one node, and anybody can be a node. And
okay, I got that.
Or a server.
Those nodes, how do they communicate?
They communicate through the protocol that the blockchain has created.
Okay, and what would that be? Is it internet protocol? Is it a binary protocol? Is it an analog protocol? What is it?
All the blockchains can use the internet protocol to communicate, and they can also use their own protocol to communicate. But they definitely need to use the internet to get to each other.
Is it peer-to-peer then? So like, let's say my cell phone and
it's peer-to-peer using the internet protocol.
Okay, so it's still using the internet. It's not, then if you don't have internet, then you're not safe.
Because right now all the servers, all the switches and hubs that are controlling the entire internet across the world are programmed to run off of TCP/IP version, whatever it is, 4 or 5 or 6, whatever they're on to. It's still TCP/IP though, and that's why the blockchains need to know how to convert their protocol for communication, which is probably came with the blockchain developer. They created their own private version of communicating over Ethernet cables that is not TCP/IP. It still communicates because it's another way of sending batch files of data. And
so it's like two-factor authentication. One, you could do it through the internet protocol, and one you do it through a different medium.
The thing about TCP/IP though is you can communicate over TCP/IP without encryption or with encryption. Most blockchains do not do anything without encryption. It's all encrypted all the time.
It's called crypto for a reason.
Right. So that's another thing to keep in mind, that everything is encrypted with blockchain. There is nothing transmitted over the networks that is not, encrypted with a password or whatever. And of course, the wherever the data is going, the other end is is got the key for that password. You know, that's just how it is. They send these, I forgot what it's called, little batch files that
So
contain
then how do you transfer the value from one
that's held on the ledger.
one
The ledger determines the
apparatus
value.
to another one? And so like let's say my chip might be more valuable than your chip just by, like, let's say the quality of transmission or the carrier, because it gives it a different value. Some carriers have higher frequency bands that they communicate with, some have lower. So it depends on, the wider the field is, the which apparatus works with, the more they value they do the conversion, the offsetting, because there's going to be a unit of
Well,
an
what I'm saying
offset
is
difference.
there is really 1,001 ways you can communicate digitally over an Ethernet cable. There's actually more than that ways. There's like probably millions of ways, and it's just digital ways of sending packets using, your own mathematical patterns, whatever pattern you want to use, as long as it as the values that you give in and the values that come out are the same every time. And so they pick between those mathematical algorithms to create ways of compressing data into packets and sending them out in bursts, of little bursts, like
You
a
mean
fax
there's different
machine.
logic gates of data transmission? Some logic gates have to go through a circuit in order to reach from one point to another. Other ones could just like
Right.
magnetically reach from one end
Well,
to
all the
another, and it
logic gates,
bypasses all the circuitry part. It just like quantum,
all of the
you know.
logic gates are going to accept all of the batches that they hear, as long as it's a high or a low, it's coming in. That's all the logic gate is going to understand, highs and lows, and it's going to convert those highs and lows from one place to another. It's not going to, and it's going to consolidate those highs and lows also to compress them into batch files to make it more, to save space and bandwidth on the network, so you don't cloud up the network with a bunch of unnecessary bits of data that could have rather been, consolidated into a fewer bits to get the same equation. So
Yeah, but
yeah,
that means it's deleting the record of route of path of where that data
no,
went.
no,
Because
no,
let's say,
no.
yeah,
There's
because if you
protocols that
use
that
a
no.
circuit logic gate, it already has like an
Logic
accurate
gates don't
measurement.
delete anything. They just convert two ones into a zero, which is then translated back into two ones. That's just how they work. These other logic gates convert a one and a zero into a zero, but that same logic gate is going to take that same zero and convert it into a one and a zero at the other end.
Yeah, but they have different speeds. That's why they're
Oh, that's different topic
condensing
then.
it.
Yeah, you're
Yeah,
right.
because circuits have a lengthier path, to reach from one point to the other
Right.
than when you transmit them through the
Yeah.
ether. It's through a signal. So it's going to be, of
That's
course,
the
it's going to be
CPU.
condensed.
How fast is the CPU? That determines how fast those gates can turn on and off and convert the data. Yeah, and it slows down. It speeds up the time it slows down the time it takes. No, yeah, no, it quickens the time it takes to get the data from one place to another. So the faster you can do all that with your switching, the faster the data gets processed.
Yeah, but the data could also be transmitted without the circuitry.
Nope, you need the
Yes.
switching to get the
Nope.
ones and zeros to move around.
Nope. Our cell phones are not attached to, they communicate without them being plugged into a wall outlet or, a circuit. They communicate, not through circuitry. There's no connection. It's a wireless
No, what
connection.
they communicate through ons and offs, signals of ones and zeros. That's it. And
Okay, but
it's
it's not like
wireless.
when you plug in your computer and you execute a command through your computer that's connected to your cable line, that's connected to your receiver box, that's connected to your cable box, that's connected to the
Yeah,
like
it's
a.
also communicating the same way, but not wirelessly. It's doing it hardwired. It's
Okay,
still
so the
using ones.
data with hardwired, it has a lengthier
Well,
route than the one that is not connected.
the wireless data transmission, if it's 5G short range, it's very high speed, lots of data, very fast.
Okay,
But
so we're
short
agreeing on
range,
that.
short range, you have to be close to the antenna or the repeater. But 3G and 4G has a longer range. You can be further away from the antenna and still get reception, but not as fast as 5G.
Yeah, because you're dropping off the internet reception. You're just using the
Your reception to the internet is still there with 3G at a longer range. It's just slower connection.
okay, but the call transmission is fast. This is just like the normal, even if you had
Well,
5G.
to make a call doesn't require much data, but to have high definition video over your
Okay.
3G.
All right. So like we're talking about the higher you go in G's, the more
The more data and the
not
higher
the more
definition the
data,
video is.
the more let's see, interrupting, I keep on forgetting.
Bandwidth.
Yeah, the more bandwidth, the more you can have visual, like the
Right.
higher streams. Yeah, higher streams rates of data.
More data, more pixels per square inch, higher resolution image, higher resolution audio. What else? Whatever. Just higher resolution everything, because you have more ability to send more data in that 1 second than you did before with a 3G or a 4G. But the range decreases with 5G, not the bandwidth. The bandwidth goes up. You get all kinds of bandwidth with 5G. You just lose range.
So Jack the Shop, I just demonstrated the Rodin coil's ability to actually output more energy than it's taking in by hooking it up in comparison to a circuit that's not hooked up to a coil, inputting the same amount of energy into both. And you could see the waveform a second ago. It was smaller on the input in the reference circuit, and on the output, it was just spiking like crazy.
But all those cell phone companies, they purchase from the FCC, they purchase 908 megahertz or whatever. And if they're streaming or broadcasting 5G, they purchase the 5G frequency from the FCC also. So you could purchase from the FCC like a radio station in the FM band, and then you could broadcast, 50, 100 miles. But you could do it 5 or 10 miles without buying anything, without registering anything. I think that's what I read somewhere. So you can get like a handheld FM broadcaster that has a 10-mile range, and you won't be breaking any laws. And that's, I believe you have to be not in the city when you do that. You have to be like away from the city.
I saw these walkie-talkies once, and their range is like 100 and something miles. And they come in a set, I think, of 16 of them. So I was thinking like 16
Right, you have
of
to.
them.
Oh, you have to purchase the repeater fee. It's a monthly fee, $5 a month or whatever, to get access to the repeater, and then you can do that.
This
100
is like
miles.
on Amazon. You buy these walkie-talkies that have a range of like 150 miles, and there's 16 of them. So what if like we
I
line
saw
them up
that. I
from
looked into
like
that.
one part of the country to the other part? Because if there's 16 of them, and each of them have 150 miles, if I put one here, and let's say one in San Antonio or Austin or whatever, it's 150 miles from there, and then another one and another 150 miles.
Maybe you're right.
You could
Yeah, you could do it like that.
Yeah, and then you could have actual communication from one end to another, just using, one set of device, because they're connected in a sequence and they communicate within a radius of 150. So if you have, walkie-talkie
If you
one,
wanted to
all the
go
numbers-
300 miles, though, you'd need 3 people,
more
3
than 300
walkie-talkies.
miles. I'm telling you, it comes in a set of 16, 1/6.
Right, but the thing is, you could also order like for $5 a month connection to repeaters that go across the whole country, and now your walkie-talkie can go across the whole country for thousands of miles.
Mike, the whole idea of research and science is trying to figure out always a different route from the mainstream. and always not having it, your data or your connection controlled by a third party. You just want that control to be within your own group.
That's
So by
shortwave
you
or
understand?
CBs. CBs
Yeah,
is the only way.
like if I want to do a connection from, let's say, from here to Miami or from here to Michigan, or some of our friends are in Canada, like without using any monitored protocol, it could be done with.
AM does that.
Yeah, but you still, again, AM, you
AM's
have to file with
worldwide.
the FCC, right? But you still have to file with the FCC for that frequency. But with walkie-talkies, they're not. You don't have to file with the FCC.
Well, you could choose another band like SW, sidewave, shortwave, and they have another one. There's a bunch of bands that they have, but I don't know.
I don't know. I'm more into. I'm one of those people that likes to experiment with these things. Not necessarily like you take things as, oh, you're breaking like to be in.
I don't know the history of the
the
FCC,
law
but I'm
or
thinking
not
maybe
law.
around
For
Tesla's
that,
time
I
they
could care less
started
about
to,
the laws. I'm more
incorporate.
interested in the experiment part. Can it be done? And then we'll think about whatever the regulations, but can it be done? Because that's what communication technology. That's how you advance things. If you don't test things without an interference,
No, you
then
can
never know if it
transmit.
works or not.
You can transmit on any frequency you want and receive. But if it's an FCC regulated frequency, then eventually they're going to home in and say you
Okay,
gotta.
but is a walkie-talkie an FCC regulated frequency?
No, because the walkie-talkie has a range and it's broadcasting on frequencies that are not regulated
So if
by
I
the FCC.
plot one device in one latitude, longitude, 150 miles, another one, another 150 miles, another one, and another 100 miles, and so forth till I get to number 16. Could you imagine that amount
What's
of
regulated by the
distance?
FCC is the amps. When your transmitter has
Okay,
like
Mike, you
those
don't want to understand.
walkie-talkies are low amps. You know what I'm saying? They don't go very far. So the FCC doesn't worry about it.
And means we are capable of transmitting signal using something that is not regulated from one.
Right, you could turn up the amps, and then
longitude.
the FCC is going to,
Oh my gosh, you're really stuck up on the FCC. But all right.
You need amps to go further, and that's when you get busted. Is you're not allowed to go past 5 or 10 miles from your transmission location.
Then why do they sell them to the public that have 150-mile range and anybody could buy it?
I saw those, and I haven't tested them, and I did read that, and I believe you have to pay.
You can buy a repeater, a 3-block repeater, and position it in different places, and it's your repeater, it reads your signal, and it's not regulated either. And this is, you could put it anywhere. You could stick it to a public tree if nobody notices it, and it could be a repeater. Like they come in a pack of 3, and you could use that. Like if let's say I have my internet at the house, I could use that repeater to give you internet if you are.
If it's encrypted, then maybe, yeah, because nobody can hear it.
Like we could share the same internet, even if the distance is not close. Just depends on the range of those repeaters. And they sell those too.
If it's encrypted, then you can do it all day long, globally, as long as nobody can hear it, except for the people who have the encryption. Yeah, because
you're buying that. You're buying those, set of repeaters all in one system. They identify each other's signature, each other's broadcasting signal. So yeah, you understand, science is cool. It's not, you don't always have to do it how everybody else does. This is the fun of experimentation. If you don't experiment with these things, and how would we ever learn what we could really truly achieve?
No, you can broadcast all over the planet, no problem. Just the FCC will probably be in the way. That's all I'm saying. Eventually,
no, they will not. No, they will not. If it's a device that is being bought from a company that has a tax ID that is recognized by the government and they pay federal taxes on, and they, then how? I'm not buying it from, something that is not a
some of these devices come with the
merchant service. I'm buying it from somebody that is regulated, that pays, taxes on the profits that they make. So you can't tell me that if I buy the system from Amazon, which is, a recognized stock market public, it has public shares and is recognized by the Security Exchange Commission. It's recognized by pretty much anything, any department globally as a supplier for goods for for the public. And those goods are and within legal parameters. Otherwise, the government would shut down Amazon if it was selling illegal products.
I'll be right back, guys.
I think the walkie-talkies they're selling are perfectly legal. There's nothing wrong with them. I don't know why you think they're illegal. It's
You
just,
thought they were illegal. I did not. I told you, like, they're sold on, the World Wide Web from a company that is globally recognized as a,
yeah,
a
there's
company. Yeah.
frequencies that are unregulated, and there's frequencies that are regulated. The walkie-talkies are probably on those frequencies that are unregulated. You just got to make sure if you're going to broadcast that you're on those frequencies or whatever. But then again, you run into issues of everybody being able to hear, and then you have to encrypt your signal and do stuff like that.
They're already encrypted because they follow
there
a
you go.
certain, because they're part of a pack. It's like, they're part of a grouping of recognized devices that can communicate within their own, network. So
I bought those walkie-talkies. They did go pretty far. I think a mile or something like that, half a mile. I started having problems like that half a mile.
I'll send you an email with the ones that I'm talking about to show you what I'm talking about. Mike, I've thought about a lot of these things. I have my reasonings why I was thinking of these things, what I wanted to achieve with that. So I've done my research on this stuff, like big time.
Some of those channels on those walkie-talkies are access to the repeaters, from what I understand. And then you get all that range. I have never used that part of it. I'm not really a radio
like
enthusiast.
Walkie-talkies are supposed to be a private system that is not, it communicates from point 1 to point 2, from apparatus 1 to apparatus 2. It should not, the signal should not be bounced off of anything that anybody else has as a signal.
I don't think you can buy a walkie-talkie that has encryption yet. You could probably find one that does. I don't know. Generally speaking, I haven't seen any walkie-talkie encrypt from one walkie-talkie to the other and make it so that nobody on that signal can hear what you're saying. So that's the thing about walkie-talkies, is anybody in range could hear what you're saying. So it's not private unless it's encrypted. And you can encrypt the signal from a walkie-talkie to one walkie-talkie to another. I don't think that's your regular walkie-talkie, though. That's a pretty modern one.
It's like frequency scramblers. Like the connection between one walkie-talkie like even if somebody were to tap into it, they can't, because the frequency is scrambled. And one holds the key to the next, to the next, to the next, for that frequency to be gathered and reformatted into the audio. But it happens at such a quick, that, but in the process between from point A to point B, that would sound like if somebody was to try to tap in, it would sound, like they cannot understand what it says because the frequency is scrambled. And then it's like Lego pieces, and then it's reconfigured back into the second device and transmitted as, audio that we can comprehend or understand or hear, properly.
Yeah. Believe me, if they wanted to descramble your encryption, if they really had to, and they could record it, they would. But it's a lot of work, a lot of effort. You probably need a quantum computer to do it fast enough. But yeah, you can descramble, decrypt the signal if you had enough time and enough processing power. It's not going to happen fast, though, depending on the level of the encryption and the processing power. If you had a D wave machine or the quantum computer, then yeah, I guess the government has one of those. I think two governments have. There's two of them out there, and one and two governments that have one.
Google has a quantum computer. IBM has a quantum computer.
Yeah, that's
A
what you
lot
would
of
need.
different universities have quantum computers, but they're not the same rate of processing power. They're on different generation levels of processing power.
Yeah, they're like multiples of square roots more processing, not just power, but yeah, it's a big topic. But
Yeah, because like you've got that the rare isotope that is the brain of the whole computing, the quantum computing. It's just electron transactions that which could reach the higher the processing power, the higher that they're going to push those electrons into the different blocks of chips that could reach the core, the kernel. Understand? Like, yeah.
they created an uncertainty principle on each side of the switch. Either it's a high or a low, typically. They made it so that each side can be a high and a low using doping of materials on the two sides to
Like
create
superposition,
an
either a zero
an
nor a
uncertainty.
one code. And that, this is what the whole thing about superconductors is to get data into the superconductor, like binary bits, neither a zero nor a one, to have it at either or.
Personally, I don't think that thing should even work. The quantum machine, I have a feeling they're BSing us that they got that thing working properly anyway. Because if it's the electrons like undecided
but
of which
it's
side to
free.
go, I mean, how
I'm
you
still on
gonna
my break,
trace
but
that.
that's
them?
awesome, Mike. That's hilarious.
It's a
You think
frequency
they're
that is not
BNSSing us?
regulated.
That's an interesting theory.
Just
It
think
might
about it
be.
though.
It might
If
be.
they created the two sides of the switch to be a high and a low, when typically it's either a high or a low, now they're making it so that it can be both. And they did that by strategically doping the switch with materials. Then the electron is going to have a difficult decision to make, which way to go on each side.
You know
of the
why
switch.
they were so excited about the LK99, that room temperature superconductor? Because you don't have to have such, a big facility for cryogenics, nor
I'm not filled in
nitrogen to
on
cool
that.
it down.
What'd you call it? I haven't done the research on this.
The
room temperature.
LK99, it's supposed to be the thing that they discovered a superconductor at room temperature. It worked for,
LK99, is that what they're
yeah,
calling it?
yeah.
First time
But
I've heard that.
man, it's been out for like maybe 2 years already. They've been
Yeah,
doing
I
experiments.
don't follow physics like that.
Okay. Well, this thing, if it works at room temperature, all the facilities that they spend billions of dollars on to make them at below zero temperature, so they can like basically freeze a binary bit in time. The colder it is, then the longer it takes for that that electron charge to transmit from one plate to another. And so, but if it's room temperature, it means at one point we go and all have like like quantum computers in our homes, like our regular laptops, where their
Well,
processing
yeah, a
power is
superconductor means
astronomical.
you have no energy loss in the transmission,
Yeah.
which means no energy loss. So, yeah. So there's no signal loss. The data's never lost either. Whatever, if you're using it to send data, the data's
And
never
it has
gonna get
the like an infinite amount of storage space. That's the important thing. It's the storage space. It's like you'll never run out of storage space for your data. Like now it's not anymore calculated in how many gigabits does your apparatus can hold of memory.
What is LK what?
99, I think that's what they named the material that they found or
And
they made at a lab.
do you know anything about the composition of the material? What's in it? Magnesium? What is it?
I have no idea. But they talked about it in like APEC, I don't know, many times, and then different channels.
Well, if something like that exists, think it would be blowing up everywhere by now.
No, they disseminated the information to the public, and then they do the hush hush on it, and then all of a sudden,
I don't think you could hush
like,
hush something like that. A material that they know that it exists, and if they know it exists, they know what the materials are, and that's going to get out. You know, there's no way you can hush hush something like that. Everybody, including GE and General Electric
yeah,
and
but
Power
remember this.
Grid all over the
Only
world is looking for this.
only very high tech research labs have the access and capability of manufacturing this, so they already still have control on the manufacturing process of this material.
Do you
So
know
it's
where
still
what
out of
country
the,
it's coming out of, or anything like that?
I don't know. I think it's in the United States.
United States. First, I'm
I
not
think.
following this.
I'm not sure.
I didn't ever hear about this. Yeah. I don't know. Yeah. If I were in Skunk Works, I'd probably know. And I wouldn't be able to tell you.
Man, it was public. It was public. It wasn't. They didn't hide it from anybody. It wasn't. But it was like a new discovery, and everybody was talking about it.
Oh, yeah. I'm not watching TV. That's probably the problem.
Not even if you've been watching APEC, I'm a billion% sure.
Well, I'm
they
watching
mentioned
APEC,
a dozen number of times.
I mean, they talk about materials, but
Exactly.
It wouldn't be hard to demonstrate a superconductor if you had it in your hand. You could just send one amp in one side and out the other, and there you have it. One
Okay,
amp on the other.
Mike, really, like, you're talking to me about something that I learned, I saw, I listened to,
I don't know. It might be more difficult than I make it sound to demonstrate something like that, because you wouldn't see much transfer going on since there's no resistance going in the material. You wouldn't even see light because there's no resistance, nothing to create heat or emissions. The energy would flow right through the material. There would be no resistance to resist the energy, and then you have back emissions and heat, light, some form of spark or whatever. You wouldn't see any of that if it's a superconductor, because there would be no competition for allowing the energy to flow from one channel to the other. No interruptions.
If you're using it for the encasement of all of information, the core would be the resolution of the whatever the Q is, or the whatever question you're asking it, or whatever problem you want it to compute. It would come to a resolution point, and that would be, after it does all these different billions of calculations, is going to have an answer. That answer is going to be that last thing, and it's not going to fluctuate because there's no other answer of possibility in it.
Yeah, I'm not a mathematician, Lulu. I don't try to be one. I don't know. Formulas, I kind of put them behind my past. It's like I did the schooling already. I have no application for formulas. The world's pretty simple, and if you want to stay on Earth, that is. If you want to go to space and all that stuff, or in the deep sea, and then it gets complicated, and you need all these formulas for everything. So,
well, I absolutely want to go to space. Why wouldn't
I? That's math that I don't even want to think about, because it's just not. I don't know. I don't think math. I don't think about it. I don't know why. It's not my passion, I guess, to think about any of the math that's out there. I kind of gave up on math. It's great. Yeah, you can see it works. I just gave up on understanding its application in the real world. Complex math, not simple math.
And mathematics is I could never wrap my head around high-end mathematics.
In the real world, it has no application. It has application in the quantum world. It has application in the macro.
Yeah, like I
you
I
know,
learned things not numerically,
astronomical
but through
world, you know.
example.
Yeah,
Mm.
but they all start at the quantum and get scaled up to the real world.
If you're doing the deep dive into that stuff, then you're going to need to be thinking math all the time. Because there's no way
It's
to do a
called
deep
data
dive.
science. That's what data science is. You know, the science of what data is.
Yeah, well, I
What the value of
consolidated
it
all
is.
that math to a more simple way of understanding, going from ones and zeros.
I'll check
to-
Discord in a second, Chance. Thank you.
It's just binary. You got 5 lines of ones or zeros, and you add them up. The first line is 1, I think. Second line is 2, and the third line is 3, and the fourth line is 5. And that's all on paper already. And from there, you can,
Ooh.
use those numbers to add them up from
Hey, Mike.
binary to turn them into octal, which is
Mike.
1, 2, 3, 4, 5, 6, 7, 8. Yeah.
Sorry, I didn't mean to interrupt you, Mike, but I got an interesting development. One of our subscribers sent us his modified Bedini, what he uses for powering his Bedini circuit without a 12-volt battery. So I wanted you to take a look at it, and yeah, it was really cool. It was a little bit above my head, so maybe I'll have you take a look at it and see what you think.
Okay.
All right, give me one
Who's
second.
the user?
Shanjax.
Shanjax?
He's
What's up, Shanjax?
yeah. He's
Yeah,
been
see it.
a subscriber for a while, so he's been in communication with me about potentially helping me with bringing this into a modified Bedini circuit to work with the coil. So and again, this is a big undertaking. We're gonna need a whole team if we're gonna get this thing to work, I think. So
I mean, I'm pretty good at analyzing switching circuits, and
yeah, that's why I wanted you to look at this. Give me 1 second and I'll bring it up.
when it comes to calculating the math, I'm average at that.
And that's where we can bring Victor
I just
in.
use Ohm's law for
Victor's the
everything.
mathematician.
The Ohm's wheel.
But yeah, we got a whole team that I think we can crack this. And honestly, I wouldn't have been able to get this far without you guys. So I appreciate all the help. Let me change my camera here.
I know how stressful it can be. I remember, building the first circuit I built was a binary clock.
Mm-hmm.
And gratefully it worked. I was happy, but then the next thing was a wireless video audio transmitter. And that took a few goes. Didn't happen right away. I put a part in backwards or whatever. Things like that happen. It's not easy. You got to really look at that circuit and get everything right. And don't even start asking how it works. If you're trying to build it and it's got more than 10 pieces put together in there, components, it's just going to get too confusing to understand it fully on how it works. It's just easier to understand it all after you put it together. Let's just say the revelations don't come until you do the replication.
Mm-hmm.
But the excitement of doing the replication, even though you don't know what you're doing and what you're building or why it works the way it works, that whole process is the learning
Oh, there we go.
process,
Okay, so yeah, he's got a whiteboard up here. Also. And he's good. Oh, it looks like he's helping me with the connections too. Awesome. So I'm also gonna ask him to bring up that circuit that he posted as well, or maybe I can post it. I don't know if I have access. I
But
can
that
also
FM
just bring up
wireless video audio transmitter had like about 50 components in there,
Okay, I'm gonna just share my screen real quick with you. Here it is, right here. So this is his circuit diagram. Let me zoom in. Let me see if I can zoom in a little bit. Won't let me zoom in. Okay, I just saved it. Let me see if I can
It looks like a
put it up
rectifier.
here. But in the meantime, I do have his whiteboard up here that I wanted to share as well. So he's got it right there. Awesome. Thank you, Shanjax. Simulator is interactive. Ooh, this is interesting.
Internet's the best for communication because you can encrypt everything. You know?
Mm-hmm. This is really cool. It's hard to see it. Let me see if I can zoom in a little bit more.
I mean, StreamYard doesn't encrypt, but you can if you want to.
Mm-hmm. So it looks, I think he said he's using 2 Bedini circuits combined. So it looks like, as you can see, like one on the bottom and one on the top, maybe.
Zoom in on his circuit.
Let me see if I can.
That's where it's all at.
Oh, he's got waveforms down here too.
Wow. Oh, look at this. Let's see the transistor.
Now, see, this looks like the kind of spike that I'm looking for right here. You see that? These two. I'm sure if we zoom in, they might look more like the H wave we have. Not exactly, but maybe close. Oh, that's the screenshot of the simulator. Okay, so this is a simulator he's using. I wonder how we can get access to this simulator. This would be cool to actually check out. Oh, and it's actually showing the waveforms in the simulator. I see. This is cool because we need something like this to show us exactly how to build our circuit to get that H waveform that we're looking for. So here, let me just show you guys real quick for anybody who hasn't seen it yet. But this is the H waveform. Oh, I didn't have to do that. I could have just stayed on the same screen.
Looks sort of like a ZVS circuit.
Okay, so that's not it. Okay, so this is the H wave we're looking for, right? So you can see the transient spike on the top and the H kind of shape. And then on the bottom, transient spike and then the inverse H shape. And it just keeps on going in that same pattern. That's what we're looking for. So if you found any waveform similar to that, that is what is going to be powering our circuit, I believe. Switch back. But yeah, this is so cool because this is exactly what I was looking for, a simulator that could handle the back EMF simulation. Oh, he gave me a link to the simulator. Hold on, let me see. Discord's a little... Oh, is this it? This might be it right here.
Well, it looks like he's using the AC signal to trigger, using the top half of the AC signal to trigger one transistor and the bottom half.
Oh, Mike, look at this. Look at this.
Yeah.
This is so cool. Wow, great job, Shanjax. This is going to help us out tremendously. We're going to start using this simulator for our circuits from now on, I think. We're gonna have to. Look how well that's putting out all the waveforms too, showing us exactly what's going on. And all the different, I'm guessing those are different waveforms for different parts of the component or the parts of the circuit. Let's see. Let me drag this over here so I can see it better. Okay.
ZVS has a similar configuration with the capacitors.
Uh-huh. Oh, okay. So it's similar to a ZVS. Interesting.
The capacitors,
Oh, I
change
see.
the signal dimension.
Yeah. Okay, so look at this. I think the different colors correspond to the different colors of the current here. You see the green, and then you see the yellow moving electrons flowing. I think that's what I'm looking at. Is that what I'm looking at, Shanjax?
He's gotta explain
Component
this.
turn blue. Note the flyback where it goes on the right side. Note the flyback where it goes on the right side.
Right side.
Yeah, where it's going on the right side. So the blue, he said, highlight the component, and the blue is the flyback. I think that's what he said.
Oh, I see. The blue.
Or the
the
blue highlights the part.
Those are coils. Okay. 12 millihenries. Let's see it.
No, red negative, green positive. Okay, it's like a heat map. Okay, that makes more sense. When a scope has a mouse focus, blue highlights the component. Okay, so blue's just the highlight. Green is the forward flow. Red is the back EMF, I'm assuming. So he's saying on the right side.
Use a square wave or a sine wave?
He's saying, I don't know. He's saying on the right side, though, pay attention to the back EMF direction. So look at this red direction here in this right side.
Right. So the capacitors will fill up, and once they're filled, they'll trigger the transistor.
Yeah, see how it's switching? Yeah, it's filling up and then it's switching. Oh, this is cool. Okay, so where exactly is the output, the load right here? This is the signal, 2 kilohertz. And that's the signal. That's within the range for our coil, 1 to 2 kilohertz. Let's see if we can change this to 1 kilohertz and see what we get.
What's the name of this program?
It's called Falstad.
I'm too lazy to learn a new program. I'm just so tired. All these learning curves. I'm 50. I'm done learning. I'm not going back to school. I graduated school when I was 17 and went straight to work. Looking for, well, I already had a job, but just got a better job, put it that way.
Yeah, there's so much crap to learn.
I went back to school, spent 35 grand, and I think I kind of wasted it. I mean, it's a great education. Got my electronics degree from ITT and whatever. Today, anybody sees that degree, it doesn't mean peanuts. Everybody's got to have a bachelor's nowadays and a PhD.
Mike, education is a tool for you to research in anything you want legally without
if you got a bachelor's and a PhD, you get turned down because you're overqualified.
200 nanofarad capacitors on the right. Right. It looks like positive energies go into the one capacitor and negative energies go into the other one.
The ZVS kind of does something like this.
And then he also said, when the top switch closes, the bottom cap charges and vice versa. Yeah.
2 coils.
Oh yeah, he said the best part is how easy we could share it with each other. Yeah, that really is a good feature, because if we're trying to troubleshoot something and I need Mike to look at something that I'm building, this is a great option.
Well, when you get the links
Um,
for this program, send it to my email.
Oh yeah, sure. I'll put the link for this in the email as well. The circuit. All right, I'm gonna send it to you right now, Mike. And I'm gonna send it to Nathan and Gerald as well, because they might be interested in this.
And quite frankly, I didn't even try to learn this switching stuff. I just couldn't stop myself. I wasn't trying to learn it. I didn't want to learn it. I wasn't hoping to learn it. I just thought that if I'm going to do anything as a career, it would be this, like technical stuff.
Mm-hmm.
That's the only thing I would enjoy doing. It wasn't like I had to learn any of this stuff for any single purpose, but it's definitely valuable information. Especially the generator.
I'm gonna send this link to you first, Mike, because I don't know. It's a weird link. It does not turning blue like you can click it easy. So let me know if you can click that easy or if you have to just copy and paste it. It's really long.
I just think that the Tesla 3-phase generator is the most important thing anybody can learn in the field of electronics or electricity or whatever.
Okay, I sped it up to see which components are being powered. You can see them flicking on and off.
What I believe is happening here is that the AC sine wave, the top half of the sine wave is triggering one transistor, and the bottom half of the sine wave is triggering the other transistor. At the AC signal frequency.
Yeah, the top half is it's switching back and forth. The top half is powering one capacitor, it looks like, with positive energy, and then the bottom with negative energy, switching back and forth with these series of resistors.
You can trigger with a negative voltage using a reverse bias.
So I'm gonna actually build this. I'm gonna build this one. Where's the output though? Here, here's a square waveform inputting here. So there's 2 waveforms. Waveform. Oh, this is AC. Okay, so this is AC and this is square wave. Okay, so we have AC and a square wave. So we'll have the AC and the pulse with modulator attached. Both. Okay, that makes sense.
It's not either or. It's both.
Yeah. I'm not sure where it connects though.
I think he means either or. You can use either a sine wave or you can use a square wave.
Oh, it's not connected. Oh, I see. It's not. I'm like, where's it connecting? Oh, yeah. He might mean you can connect either or. Okay.
Right.
Hold on. I can't see the chat when I'm doing this.
They both have a top half and a bottom half. Both the waves have a top portion.
Oh, they're encoded. Like current speed adjusted. Yeah, I sped it up because I wanted to see like the pattern of components flicking on and off. Yeah, you say you could swap the input now. Okay. Where's the output though? Is this? Hey, Shanjax, could you tell us where the output is on the circuit? Like, where am I actually connecting the load to?
The coil
the capacitors.
Is the load.
Oh, okay. So the capacitors right here is the load?
Yeah. There's only 2 coils.
Oh, that's right. Okay, so we could just replace one of those loads with some LEDs or something.
Right, the two coils can drive the
Or not
motor.
replace it, but put a LED on that capacitor.
Jean-Jacques, did you look at the flyback loop thing I made? Sort of like this, kind of.
Oh, he said the output is the field itself. But I'm sure if we need to attach a load to anything, we could attach it to one of these capacitors. Correct me if I'm wrong on that,
No,
Shanjack.
the capacitors are controlling the switching frequency. You can't.
Oh,
But
are
you
they?
can
Oh,
attach
so
it
that's
to. You can attach. The coil is the load. It is a load. So whenever you put.
so okay. So this is just a method that's going to be producing a strong electromagnetic field and not really have
Right,
an
the
output
magnetic
attached
field that the coil
through
produces
the
is what you're
wire.
going to use to spin the wheel.
Okay, so this is just for the magnetics. I'm gonna
Right.
try this, but regarding phase 3, we're gonna need
Output
something
is
that's gonna
on a
be able
motor.
to power, right? We're gonna need something that's gonna be able to spin a
Right,
rotary
those
and
Ben, that's
power
those
load at the same
coils
time.
produce a magnetic field that will push a magnet that's attached to a wheel.
Right. So then maybe another circuit attached to the rotary to actually produce the output energy as well.
What he's saying
Because
is
we
those
want to spin
coils.
some. What I need, without giving too much away, Mike, is I need something to spin, a rotary to spin like a wheel. And at the same time, I need to power a load. So I can just use that spinning
Right,
motion,
but you see
right,
the
to
two
generate the
coils.
electricity for that.
You see the two coils. You have a vortex coil that you have a bifilar.
Yeah, the two coils
there, right?
no, that's the resistor right here. Two coils right here. Yeah, so this is just a magnetic field, and I'd have to, if I need to put a load on it after that, I'd have to make just another circuit to capture it off of the rotary. That's all.
Your bifilar would be those two coils.
Yeah, so this would be channel A and channel B, or vice versa. I don't honestly think it matters which channel is which.
It might matter the polarity of the connection on one of
Right,
them.
the polarity. Yeah, yes, the polarity of connection will matter. I believe that will matter, especially
Only
in
on one of
correlation
them,
to
though.
one
You
another.
only need to
Like
switch
if you
one of them.
right, but I'm saying like in relation to coil, yes, the orientation of the polarity where you connect it is going to matter. But I'm saying like coil or channel A and channel B, they can be interswapped. It doesn't really matter, I don't think, right?
Right, but if your magnet's not spinning, you can flip one of them around to get maybe.
Oh, I see what you're saying.
Yes.
Yeah. So this,
Not both of them. You want to leave one the way it is and just flip the other one around.
so this is also very close to our resonance range for the PWM, which is 3 kilohertz for the pulse DC. And Shanjax, you have these frequencies set to a specific frequency. Should I not change these, or can I play around with them and maybe tune it, use that to tune it to my coil? He said there's also one coil variant. He said the 1 ohm resistors can be ignored. Yeah, I don't have anything low enough for 1 ohm, unfortunately. So we wouldn't be able to put those in there anyways, but I guess you just ignore this and just hook this directly up to this. Yeah. He said, sure, play around. Ideals depend on the coil inductance, resistance, and recovery. Yeah, so I'll probably have to play around when I actually get this built and hooked up. I'll probably have to play around with the frequencies to find the sweet spot again, to tune it. And it might be different. Who knows?
You can lower the value on those caps to lower the microfarads to speed up your frequency.
Mm-hmm.
So the less capacitance they have, the quicker they fill up and the sooner they trigger the other transistor.
Well, I think the easier thing to do is just leave the components and just adjust the hertz and monitor, like, what I'll be doing is monitoring the voltage on the input and the output. And specifically, I'll be looking for a spike on the output. So if we have any kind of spike of voltage on the output,
I think
that's how we know it's our sweet spot.
to answer Stephen's question, the flyback is being used to charge up the capacitors, which then trigger the transistor to control the timing. So that's what the flyback is being used for. It's being used to create the trigger at a certain. The capacitors are there just to establish.
So I'm going to put
timing.
this right.
Because otherwise,
I'm
you
sorry,
could just use the flyback to trigger the transistor, and it'll be instantaneous. But or you can slow down the frequency by adding capacitance.
I'm going to put the link for everybody in the preliminary research guide for phase 2 at the bottom. Give me 1 second.
Right. Well, yeah. Right, banked by the capacitor. Back to to switch the switch again. The other transistor.
Okay, so if you scroll at the bottom there, you're going to have to copy and paste it. It's a really, really long link. It's like an encrypted link or whatever, but this should give you access to the circuit. You guys could play around with it and see what you got. I'd like to see what happens when we actually build it and hook it up to our coil. It doesn't look too complicated, and I mean, it's going to take me a little while to hook it up, but I think this is very possible. We'll probably have to use 2 breadboards though for this one. I don't know. What do you think, Mike?
No, this is a.
You think we could fit this all on one breadboard?
This circuit can take your 60 hertz from the wall, and by changing the capacitor values, you can turn that frequency into anything you want, from 60 hertz to whatever.
Oh yeah, you're saying I don't even need a signal generator. I could just change the capacitors, and yeah. But once I know the sweet spot, I can do that. You know.
Well, that's not what I said. I said if you were giving it 60 hertz, it's not putting out 60 hertz unless the capacitors are sized correctly to keep the 60 hertz. But you can change the capacitor values to turn that 60 hertz into, let's say, 5,000 hertz. Because one 60 hertz cycle will fill up a smaller capacitor really fast. And not even the whole cycle, less than the whole cycle of a sine wave will fill up that small capacitor. It's just, yeah, you can use those capacitors to adjust your frequency. That's what I'm saying. Slow them down, slow down the frequency, speed it up. Or you could not use the capacitors, but the flyback will probably keep it triggering. But your frequency will not be controlled. It would be uncontrolled.
Wow, you see this right here? This looks like the H wave we're looking for. Look at this. You see this?
The capacitor's on the right side.
Well, almost. There's a little gap in between. Mine doesn't have that little tiny gap. That's just the duty cycle though, right?
Well, the signal comes in on the left side and fills up the capacitors on the left side, and then feeds it to the transistors to the right. It's pretty interesting. This could take me a few days to fully understand, maybe longer. I don't. Whoever wrote it needs to explain it. Jean-Jacques.
Shanjax, yeah, he's in the chat right now. If you got any questions for him, load currents there, and then
it, get on the stream and.
But look, then here's another one. Here's the diode, and that's that H wave, almost like what we're looking for, that shape. So I mean, it's here in the circuit somewhere. We just gotta. I think this is the.
Oh, those diodes that
this
you were
is-
just pointing at, the ones pointing up,
Mhm.
that's, sending the top half to the top, the top half of your signal to the top,
Mhm.
and the bottom half of your signal to the bottom. And the top half of your signal is 180 degrees ahead of the bottom half of your signal. So you have two 180 degrees in one signal. The first 180 degrees is the top half, and that's going to go to the up. It's going to go up through the diode, facing up.
My bad. Here's the guide if anybody wants to take a look at it. So the link is at the very bottom.
Oh man. So yeah.
Oh, I already posted it. My bad. I thought I didn't post it. Sorry. I'm trying to pay attention to too much. Oh, hey Sean, how you doing? So Sean, you tried posting this before, and I'm sorry, like I have to make you a moderator. So give me 1 second, and I'll make you a mod, and then you can repost the link. Because it won't show up for me. It'll post, and then it'll just disappear. So give me 1 second, and I'm gonna make you a mod. Okay, you should be good to go for posting that link for us now. I really wanted to take a look at that, but I wasn't able to get it in on stream to tell you that you have to be a mod. Sometimes, people start talking. It's hard to get too many people in the stream at once. So this is cool. I'm gonna have to look into this too, Mike. It's gonna take me maybe a week or so to get this ready, but I think by the time this is ready, we'll have our 2 charge batteries. We're gonna get those. I found like $18 12 volt 20 amp hour, real cheap batteries on Amazon, but $18. That's a pretty good deal for that, I think.
This circuit here is for a motor, though. It's to use those 2 coils to create a EMF field to then push.
Oh yeah, no, and it's recycling all the energy too. So depending on the efficiency, it's probably going to be really good for phase 3 testing.
Something good to spin a 3-phase generator with.
Mm-hmm. Well, I won't divulge what phase 3 is yet. You know what it is, but I'm not going to tell anybody until I'm ready to present something here for phase 2. Phase 3 is just an idea, a pipe dream. Yeah, I want to make sure I have this working first,
It's 3 sine waves squeezed into one 360 degree. It's 3 sine waves. 120
Is it 2 combining to form a third one?
It's 3 sine waves separated by 120 degrees, which is added up to 360 degrees, which is 1 cycle. So you can put 3 sine waves phase shifted by 120 degrees in one 360 degree cycle. 1 turn of the wheel.
So that's interesting. Listen, excuse me. For our dual channel
Tesla's
coil,
design.
we have to phase shift the signal 180 degrees, and we're only dealing with 2 sides, 2 channels, right? So, but that still adds up to 360, and I didn't realize that until now.
Yeah, no, this
really...
circuit is 180 degree separation. You can see it.
Or you said 120 for each? Or is it
No,
180?
this circuit here is operating on 180 degree principles.
But you also said that there's 3 frequencies and they're 120 degrees apart?
Yeah, that's Tesla's 3-phase generator system.
Oh,
which
that's
is-
Tesla's. Okay, so that's a different, but still, we have
That's for
that
generating
360
power.
degree. Yeah,
Right.
it's adding up to 360.
Right. 120 degrees shifted by 120 degrees, 3 signals of alternating current phase shifted by 120 degrees. Gets you
Interesting.
3 phase.
I don't know if that's significant at all, but I don't know. It's just, it struck my brain as something to keep note of.
Well, the one way I look at it is you turn the wheel one turn is 360 degrees. 2 turns is 720 degrees, right?
Awesome. I'm going to check this out right now. Let's load up. I have to copy this from the stream.
But you can create 3 alternating waves or 3 AC pulses within one 360 degree turn by lining up magnets to spin over 3 coils in a certain way. Tesla came up with that way. I just think it's ingenious, man, because it creates a constant alternating current wave of generating power. It's just perfect. You could, add a 4th phase and a 5th phase and a 6th phase if you want, split up the 360 degrees however many ways you're able to do it evenly, and create, a 6th phase or a 12th phase or whatever. But it's not necessary, because 3 phase is already, it's perfect. It's a perfect way to make power that's regulated, not unregulated, like regulated, steady power that's not fluctuating, and it's coming from an analog source. It's even more clean of a power than what the river stream offers. Or, it's like having a rope system on a pulley. One side has 100 kilograms coming down the cliff, pulling up the other side with the same 100 kilograms of force upwards. But that distribution from one side to the other is perfectly evenly distributed, and there's no vibrations, and it's a steady flow of transfer of energy. That's how I see the 3-phase Nikola Tesla generator. And I think it was a single purpose design to be a generator. Its single purpose was that of a generator. But the world turned it into a bunch of motors everywhere, and they work great, and they are even better at using power than a DC motor would be. And for that reason, they guzzle power and they waste power. They're not designed to use power. They're designed to create power. For locomotion or spin, the DC motor is designed for that, because it's the most efficient way to turn the wheel. Using an AC signal to spin a wheel, it'll work just as good as DC system, but you'll be using more power than you would with a DC system, for more than one reason. The first reason is it's not designed to be spinning wheels, the AC 3-phase system. It's designed to generate power. And that's the truth, because after you look at it and you see how evenly it spreads out the three AC signals in one turn, there's no. It's like, this is ingenious. You just like, this is. And then you spin the wheel and it puts out the power, like the lights go on, turn on, like so efficiently. I built a 3-phase generator twice with, a plexiglass disc and some magnets and one coil, not 3-phase, a single phase with one coil. And when you pass a north and a south over the arms of that coil, you get alternating current. But you can line up more than one coil within that circle and pass north and south magnets over these coils in many ways. And Tesla figured out one way to do that. A 3-phase generator.
So it says optimization of energy using vortex coil technology. This study highlights the prevalent challenge of energy losses incurred in electrical and electronic systems, providing solutions to reduce or eliminate these energy losses to optimize energy. Marco Rodin, an American, has successfully furthered the concept of the vortex coil technology to what we now call the Rodin solution, and it is now universally applicable in science, biology, medicine, genetics, astronomy, chemistry, computer science, physics, and astrophysics. Crude versions of the Rodin coil, created and tested by leading scientists and engineers, show 60% more efficiency than anything presently used in antennas, computer research, or life-saving medical devices. Over the years, some techniques have been postulated to optimize energy-enhanced technology efficiency. Still, in this report, we shall see how the vortex coil technology tackles issues of insufficiency in technology. This is awesome. So it doesn't say specifically it's getting over unity. It says 60% more efficient than presently used in antennas and computer research. And I think at current, we get anywhere from what, like 30 to 50% efficiency at most, out of most systems.
It is interesting how you can, spin an electron through or vibrate an electron over a conductor with a certain geometry and improve efficiency.
I'm curious to see if they have any recommendations of winding and connecting. Here we see one without the interference pattern. Regular coil to toroidal coil.
I've seen that happen with the cash coil, and it's just a standard coil, but it has nanocarbon coating on it. And it seems to be more than efficient.
Oh, here's some test results. Here we go. So they put in 223 volts and got 225 volts out. But other than that, below that point, they're getting minimal difference for this coil. And this does have an interference pattern, but this looks, this is different. This has got the coils round around the outside vertically in a circular motion. Let's see what this says. So it's very minimal. Measuring voltage resistional copper requires coil configuration like this one across. From the observations, we see an increase in voltage causes the current to increase according to Ohm's law. Oh, here's the current chart. That's what I was looking for, the current chart. which states that
Oh,
voltage
oh.
is directionally proportional to current. The formula is shown. Okay, so this is nothing extraordinary, I don't think, right here. Conclusion: by addressing energy related.
Ohm's law does not apply with a superconductor.
Yeah, I mean, they are getting 100% efficiency, no doubt. Like, this is, like, if they're maintaining the current while doing this voltage, that, I mean, even here, you're getting slightly over unity if you're maintaining the current here, which it looks like they are. Input current. Yeah, it looks like they are maintaining the current. But, so this is actually good news. But I expected their chart to be a lot more closer to mine, because mine is getting like 155%. but no, this is good news. This confirms is more evidence that confirms what's going on. My coil is actually something that we need to take a look into, and more people need to be building these coils. And specifically, there's something unique going about Mark 1 that isn't happening in Mark 2, the fireball coil, and that's something that I need to address. So my theory is spacing. My theory is it's just, it needs to be smaller and the spacing needs to be tighter. Let me remove that. And that's really cool. I'm gonna look into that further. I'm gonna read the whole paper. Obviously, I wanted to skim it for you guys on live stream here, and give you my 2 cents while I had you. I'm not gonna go too much longer on this stream, but I'm gonna take another quick break, and then when we come back, if you guys have anything you want to share or anything you want to look into, if not, I might just go on a break and play some music for a few minutes.
Challenge Arc this one.
I'm still here listening.
Ben's at the fridge. I like his layout though. He's got it down pretty good. The whole presentation.
Yeah, he has his stuff organized.
Are you talking about the Shanjacks with the circuit?
Yeah, your whole setup, like, you know.
Oh, my setup?
Like that text at the bottom scrolling down. How did you do that?
Oh, so you could do that in banners. If you click banner, you can change your banner if you have something you want to share or whatever.
Oh, that stuff's
pretty fun. Yeah, it's cool. This is a really cool platform. It just takes a while to get used to where everything is.
Banner.
What time is it in Michigan? Are you guys ahead of Central Time? Are you Eastern or Pacific?
We're
not
Eastern,
Central.
So it's 12:03 here.
Okay, so you guys are ahead of us 1 hour. What about you, Mike? Like, it's 2 hours
It's
for you.
12
right?
o'clock also. How is it 12 o'clock in Michigan? Isn't that like all the way up north?
Yeah.
Doesn't make sense.
How do you guys fall under the same timeline? Time zone.
Right. I guess it's not by north and south, it's by where the east and west, because the sunlight hits that way. Well, it hits, it hits, it comes in east and west.
It's divided by the longitudinal lines. time zones.
Like, check out this link. It's from NOAA.
I'll take a snap image and I'll look at it later, but if I click on it, I might lose the connection to the screen.
I'll email you the link.
Okay.
It's from NOAA. You can see the weather on the whole planet, and you can see how the sun comes in.
I love those kind of sites. You know how much time I spend on Google Earth? Like zooming in and zooming out and doing the 3D and then the 2D and then, you know.
If it's just for the weather, it's a lot of work, Google Earth. But if you need to see where you're going and all that, it's different. But if you just want to check the weather and see the global weather patterns, this is it right here. I'm telling you. It's low demanding. It's just a few snapshots of the latest image of the weather.
I want to find like different, you know, there's an asteroid like approaching Earth. Like in 16 hours, it will be the closest proximity ever, you know, like a near asteroid, like a near object like towards Earth. It's not gonna impact, but it's gonna be really, really close. Like in 16 hours, it will be its closest. So I'm wondering, like, if I can find something that's capturing this, like, on video. Yeah.
There's always going to be an asteroid coming. I mean,
But this one's pretty close.
Yeah. Remember the Tunguska thing?
The what?
The Tunguska event, and then they had another one in Russia not too long ago. They got it on camera.
I think I saw something like that. Like it was so close that it really like shook that town. Like it broke a lot of windows. And things
Right,
like that.
right, that's right. I can't remember the town, but yeah. That's freaky, you know, if that went over your city or whatever.
Yeah,
It's not like a hurricane or a tornado. That's something.
it's an interstellar object. Yeah.
So
It's
if you
weird.
guys aren't aware, sorry, I just wanted to give you guys an update on. If you're not aware, I have a Patreon, and if you'd like to help fund my research and get access to exclusive clips early, including episodes of Divine Science, I'll put that in the chat. And I have some interesting things that I'm going to be releasing within the next month or so regarding a new show I'm working on called The Benefactor's Guide to Free Energy Devices. So much appreciated to all my Patreon supporters. And you guys are what keep me funded and keep updates on these experiments going. So I appreciate all you guys.
You're awesome, Ben.
What state is
Thank
Michigan
you.
in? Is that is that New York? Or
You said what?
what? Michigan is a city, isn't it?
No, Michigan's a state.
The state. Sorry, I don't know
It's
why.
the big hand-looking state at the top of the United States.
What's the capital again? Of Michigan?
Detroit?
Detroit. Right. Okay. Now I got it.
I've been to Detroit.
Yeah.
I
Yeah.
think is
Worked
that
there
on the
many
East Coast?
times. I believe so, yeah.
Your
Yeah.
downtown is like in the middle of a highway web. Like it's so hard
Mhm.
to get in and to get out. It's like,
Oh, traffic is insane.
my
I hate
gosh,
working
yeah.
there.
And you guys have a really, really good hot dog, like hole in the wall place. And the thing is not,
There's all
why?
sorts of there's all sorts of good places to eat. I'll tell you one place that I always go to is called Bates Hamburgers. Or I'm sorry, not
Oh,
Bates. What's the name of it? Hold on, I'm gonna look this up real quick. But there's a couple of different really good places to eat in Detroit. Why can't I think of the name?
East Coast is interesting. I went up to Maryland once.
It's probably been 22 years since I've been in Detroit. Like 22 years ago.
All right, Mott's Burgers.
I
didn't
lived
get
in,
around
in
the United
Milwaukee,
States much.
Wisconsin, like right across from you guys. We would drive from Milwaukee down to Chicago, like, across next to Gary, Indiana, and then to Detroit, and then to Cleveland.
It's
So
funny.
You
I'm
Mott's
guys,
born
Burgers
and
has the
raised in
best burgers in
America,
Detroit.
but I don't really travel America much. I've traveled most of Europe multiple times. Some of a lot of countries over there. Not all of them though. But I've done a lot of traveling in the East. But being born and raised in America, I'm like, why am I not traveling more in the West? I don't know. But
I've
I
traveled them
did eat
both.
the East Coast once. I mean, the West Coast is like, I've never been to the West.
Somebody else was on here, I think, and I didn't see. Somebody start streaming 216. I didn't notice that. I thought that was an asset that I had loaded up. Is that his
Well,
camera's
that's
not on?
me.
No.
Play that
Oh,
video.
that's you.
It's
Oh,
in
okay.
there.
I was like, did I miss somebody? Is there somebody? I'm getting tired. Okay, so that's you over there, and that's something that you were presenting. Okay, I just wanted to make sure I didn't miss anybody on the bottom anymore. Because I know I had Lulu hanging at the bottom for a minute, and I apologize about that.
Oh, it's okay. I don't mind. Okay. I'm
Let's
listening.
see. So yeah, I appreciate that that link, Sean. That is really awesome that you sent me that link, because it's actually, I believe it's a published paper, right? Let me check it out one more time. But I believe it's a published paper where they're, obviously getting at least 100% efficiency in their coil. And they don't have an interference pattern. They have kind of like pickup coils wrapped around the donut. Which is interesting. I have to try that. But regarding the way that I have it set up, I think I think this is like, if we can get one more person to replicate my coil, I think it's time for me to start publishing something.
Well, technically, you're publishing right now.
Yeah. Yeah, but I mean, putting together a proper paper for people to go over and analyze and review and subject to scrutiny. So I don't
Well,
know.
that's called peer review.
This is
Peer
really,
review.
yeah, this is really cool. But so now that I'm thinking about it, also they might be they're probably including the input power used to generate their signal. And right now, when I'm saying 155% efficient, that's not including the stereo amp receiver and how much power is going into it. So soon we're actually going to do that calculation with the mini amp and see actually how much we can reduce that, because that is not actually factored into that 155% calculation at this moment, because we're not using it for anything practically, right? It's just a proof of concept. Yeah, I believe if we factor in that extra energy from the wall that's going into powering our preamp circuit or our stereo amp receiver circuit, then I think we're going to probably be closer to what they have, like maybe 101, 110. But that's still very, very significant, and that's good enough for phase 3. So
Quantum. How do you pronounce that? Quantum. Quato? Like from, is that like how you pronounce it? Quato from the movie, what's that movie with Arnold Schwarzenegger? Total Recall. Quato.
Total Recall. Blah, blah.
How do you pronounce it? Quantum.
I don't know. I haven't seen that movie in years. The only thing I remember from that movie is the 3-breasted Martian.
Oh man, I downloaded the HD version. You're talking like 48 gigabytes, and I have a 2K TV. I have a 2K TV. I used to
love
watch
some of
that
those
movie
upscales.
on the old TVs, you know, with the old resolution.
Some of those old upscales look great. Like Alien. Alien looks amazing on the
It's
upscale.
incredible. The resolution.
And
if you have a 4K TV, I can't imagine.
So yeah, the big TV I have to my right is 4K, and I do also have the NVIDIA upscaler option. So if it's like 1080p, it will upscale it, and sometimes it looks really crisp, like near 4K. Like not quite, but
The
it's
resolution,
really cool. Yeah.
the pigment resolution.
Yeah, so it works. It applies it automatically. Well, there's a setting that you can do it manually too, but it applies it automatically when you're watching movies or playing video games.
Like
It'll
a high definition.
automatically yeah, like if especially it works really well on low resolution. Like if you have a 480p video that's really pixelated, it'll make it look like it's 1080p. It really, really works.
So it cleans up the signal.
Yeah. It uses some kind of algorithm to clean it up, and it's really cool. You can tell like when you're really pushing it, when you have the manual setting and it's on ultra. When it's on ultra, sometimes if it's too low resolution, you can tell like it's filling in the gaps too much.
I've seen that upscaling before. It works. It's decent.
It does. It like 90% of the time it works for me.
But what I'm saying is, if you've never watched your favorite movie in a true high definition Blu-ray, full definition, not high definition, full, or as full as it can be on a disc anyway. Some films are still not full definition because they're not able to put it on a disc yet.
Think of if you watch The Matrix like on 3D. That would be awesome. You know, The
3D.
Matrix?
Yeah, never 3D though. I don't know.
Yeah, in 3D. So you could see all like the like some of the binaries pop
I
up.
did
like,
it once in 3D when it came out. It was cool, and yeah. But I
so
don't know
cool.
what it is.
I remember when
can't
I
stick
was a kid, I built a projector out of a Fresnel lens, and I hung a mirror up on my ceiling to get a projector in my room to watch The Matrix. It was janky.
I think The Matrix is the
I
best
got The
movie of
Matrix
all
in
time.
full HD also. It's
Of
amazing.
all time. I think it's the best movie that like they've ever came up with, because every time
But
I watch
listen.
it, I learn something new. Like it's like something new clicks every time I watch it. And I've probably watched it maybe at least 50, 60 times.
Oh,
What,
same
Netflix?
here. You've never watched it though at 120 frames per second. And let me
No,
tell
I
you,
have not.
when you watch it at like 60 frames or 120 frames per second, I used to use something called Smooth Video Project. And if you watch like fast action movies, where they have a lot of like fighting and close-up shots and stuff, you want it at a high frame rate so you can capture all the details. And let me tell you, watching it at a higher frame rate with Smooth Video Project, it's like a whole nother movie. You got to check it out.
Yeah.
Does it slow down your processor, or does it require a lot of?
It requires a beefy system the more frames you're pushing out, for sure. But if you have a gaming rig, that's perfect. A gaming rig will work. Any low end gaming rig.
Yeah, I wish they make it like into 3D. So a lot of the, some of
Oh, for
the like
3D,
things.
for three, I wanted to get a headset for a while, but I was thinking in order to do 3D accurately, we have to have a high frame rate. So they have to kind of like up the frame rate to at least 60, or else it's gonna make you sick. It's not gonna look right.
Mm, yep.
So that's cool. That I think they might have to up the frame rate for movies if you're watching them on the headset. That's even more for a reason for me to get a headset now.
I didn't hear about that. I seen the virtual reality thing. A friend of mine bought that virtual
Yeah, the
reality
VR.
headset. Yeah, I put it
It's
on
high
and
balance.
used it, and I was like, "Whoa!"
It's
I
cool.
lost
It's pretty
balance.
cool.
And the one thing that the VR headsets are missing, and it's coming soon, I think some companies working on it, is the ability to track where your eyes are moving. So, your peripheral, right? So you can have your head straight on, but, kind of look to your right, and it's tracking your eye movement, and it's shifting the camera just that much,
Hmm. I know they have this technology at like my school because I caught them on different things. I would be in class and reading the whiteboard, and I would like zoom in, like with my eyes on something, and then all of a sudden the teacher would start talking about the topic that I was concentrating on. But it happened so many times that I'm like, are they reading my mind? But after like, uh, um, like I left school because of COVID. I started
Mhm.
doing research on like the technology that they use at the school, and they have retina tracking software that's integrated into the classroom setting. So like the teacher would know, they would have on their side a computer that would know where the students' eyes are looking to, at what line of the lecture, or which it would help them to explain things. So I thought that was really, really cool. And for a minute I thought they were reading my mind. I was like about to go like how are they reading my mind? Like how do they know that I was looking at that line I was thinking? Like, but yeah. So yeah, you're absolutely right. They do have those. Pretty cool.
It was something else that I wanted to try to do, but I found out that it cost money. And when I found out that, I just gave up on it. But I was close to getting it hooked up. It's a very extensive process to do this, by the way. It's a mod for Skyrim, and I don't know if you know what Skyrim is. It's a video game. It's an open world game. You can go around this, like old time fantasy environment. And I was going to use this mod to enable like Chat GPT to hook up to all the AI in the villages in the game, and you can hook it up with a voice as well, and you can talk to them, and they have unique personalities and voices. And I wanted to go around asking everybody about alchemy. This was one of my plans, but it unfortunately I couldn't get it done because I didn't have the funds to do it. But
Cool. I
yeah,
think the
like
only the virtual like computer games I used to play something called Empire Earth. I don't know if you remember that
Empire
game.
Earth.
That one was a really
Yeah, I
cool
used to play
computer
that.
game. Yeah. What else? I used to play
That's a good game.
Farmville. Yeah, Farmville. Like in Candy
I used
Crush,
to play
but yeah,
Farmville way back in the
my
day
God,
when Facebook was
my
early.
God,
Yeah.
I was the queen of Farmville. Like, I figured out a system if you manually change the like the time in your phone. Like, let's say some of the crops would take like 24 hours for them to for them that you could like harvest them. If you change the date, like I would plant them and then go manually change the date in my phone for 24 hours later, and then go back into the game. I would like the crops would be ready. So I kept on doing this back and forth, and I would save up so much time. But I don't know if it's. I mean,
Yeah,
yeah,
it was very
I
time
could.
consuming. That's the point of
Yeah,
that game, though,
but
to
I
get
figured
you
out
on
glitches
Facebook
in the game.
24/7.
I know. Yeah.
I want to see if I can do. Oh yeah. So check this out. Check this out, guys. This is called the popcorn game. This is a link to it, and it's on Google Chrome. So if you're using Google Chrome, you could just click this link and enter the popcorn game with me. Let's see, where is it? Right here. Be this mean little guy right here. Just something fun I'm going to do before I end the stream. I'll put it in the chat as well. So here's the link. If anybody wants to join us in the popcorn game.
You ever play StarCraft?
What is it?
StarCraft.
No.
Like they got Brood War, the new version of it or whatever. I never played that. The old version of StarCraft.
Thanks
Yeah,
so
that's-
much, Steven. I appreciate you stopping by and
Probably
hanging out
shouldn't
with
start
us.
playing that game.
I've been stuck on Monopoly Go. I'm like at level 10. Like I have like 10,000.
Here we go.
Is it a single
Oh,
player
it up.
person, or do you play it with other
Screw
players?
you. Screw me. Okay, I'm done. I'm done. I'm done.
The Tetris game has evolved like crazy. They have all kinds of Tetris versions now.
Yeah, and you know what? I love the original Tetris on that I had on my Game Boy. That was my favorite. And the music, I still go back to the music. If I want to jam out to like some classic retro video game music, I go to Tetris.
I'm gonna set up a folder on Google Drive. I have the old Atari game simulators that work on PC though. You play it right out of the folder. Those kind of things. You don't even need a simulator. You just play it.
You just start it up. It's an exe file or whatever.
Yeah, I have a huge database of Atari games, and
Really, I've been meaning to play some Ninja Turtles myself.
I don't think I have that one.
It was an arcade, the arcade version.
Mortal Kombat.
I have Mortal Kombat. Yep.
Yeah, I used to play that one.
I got a tattoo of Mortal Kombat on my arm.
But I don't have the joystick, and it sucks on the keyboard to play that game.
I think that game, like probably the whole planet played that game.
And this was back when Mortal Kombat was kind of graphic, but the graphics weren't like, realistic like they are now.
Yeah.
And the physics weren't like advanced. So like, no, I heard stories about, team developers on the team working on the latest Mortal Kombat, and they're like getting sick and, doing research for all this stuff. They had to look up, like pretty disgusting stuff just to have reference, for the art in the game.
Oh, I didn't think of it.
Yeah.
But the game, I love the game. It's pretty intense though. Like it's intense. Especially when you go online and play against some of these like really great players.
Just learn a little bit about ninjutsu. It's like the most devious form of martial arts that exists. It's called ninjutsu. There's nothing honest about it.
I took Taekwondo, but
I am a black
that was
belt
years ago.
taekwondo.
It's not a fair fight whatsoever. That's the whole purpose of
Yeah.
ninjutsu.
I was like, I was 17 years old when I got
You
my
took it
black
too?
belt. Yeah, that was fun.
I only got up to the second one with yellow belt.
Ninjutsu?
No, I got to my black belt, and then years
Oh, that's karate.
later,
No, Taekwondo.
Taekwondo.
And then years later, like 7 years later, I did karate for like a couple of years. I think I reached a purple belt in that one, but yeah, it was fun.
Yeah, that I liked Taekwondo. I just couldn't, I was a little kid and I couldn't continue it, unfortunately, but I'd like to at some point. It was fun.
Yeah.
I went to
Martial
I went to a
originally
kickboxing place. They wanted an arm and leg just to rent the equipment. Now, not even including like the fee for the classes and all that. So
The
it was
for
expensive.
taekwondo?
No, for kickboxing.
Kickboxing.
Yeah.
Because they consider it like a gym membership. It's
Yeah.
not like yeah.
Oh, yeah. It was something I was looking into years ago, but it was just too expensive. I was like, I could spend my money on that, or I could spend my money on food.
Fair.
I think Mike fell asleep too. I'm falling asleep.
No,
I'm probably gonna end the stream soon. Oh, you are? Yeah, I'm probably gonna end the stream in a few minutes.
Good work, gentlemen. Good job.
Thank you. You too. You've been doing great work as well.
Ben, you keep fiddling there. You're gonna
You
get
guys like do
where
the
you need to go.
actual physical work, like like the true. I more do like I research. I gather information, stuff like that. But like the technical, physical part, yeah, I'm not like I try to dabble with a few things, but you guys like are way
I can
better
tell
at that.
Ben's picking up on it quick because he's catching on to everything pretty quick. Just keep doing what you're doing and you're more than halfway there.
I appreciate that. Yeah, I'll keep trying at least. Might take
You're already
a while
messing
before
with
we have
switching
something.
circuits that, how old have you been? In your 30s? Younger?
I am 36. I just turned 36 in July.
Yeah, when I was your age, I was not messing
You're
with
young.
these circuits.
You're young, man. 36.
How long
Sorry,
have
I'm
you been
just
doing
going over
electronics?
stuff. Well, that's an interesting question because I did electronics when I was really, really young. Like when I was like 8, 10, I got a Lego robotics kit. And that, that taught me about programming and engineering. And I didn't know it at the time, but I was, I was really into that. And that kind of took a back seat for a while. And then I got into computers and I built this computer. I was into computers for about 10, 15 years, mostly for video games. And then I got into networking, which is what my original, degree was going to be. And that was really boring. And I was really bored with it. And it wasn't until maybe 2-3 years ago that I got back into this stuff.
And when the first time you worked with a transistor, tell me about that.
That's you're looking at it. This is the first time I've actually set up a circuit.
Well, what about
with
the
transistor.
robotics thing you were doing there? What was that?
So the Lego robotics kit was pretty automated. It wasn't really like it didn't really teach you about circuits, but more of like engineering and programming. So
Okay.
what it had that was really cool was it was the first of its kind, to be fair and give it a lot of credit. The Lego robotics kit was the first to have visual programming aid. You know how you have like visual script where you connect one node to another, and you know, like it's different logic gates basically,
Uh-huh. Right.
and it's mimicking the programming that you're writing,
That's
and it's all
interesting.
this, you know, syntax that you got to memorize. But no, this is like visually you're connecting one to another, and you can see this is what is going on in the programming script, and this is what's happening. And it was basically like snapping, it was literally snapping together puzzle pieces in this little line of you know, if then statements, you know, and it was really cool. And honestly,
So it's
if
similar
I
to
had
circuits that you see today. It's similar, you're saying.
yeah, yeah, like
Mm.
but it was more for the programming, and you could build, like it had different sensors. It had a motor, and you'd snap them together to your like your central processor, like your motherboard that
And
you
this is called the
programmed, and then
syntax language.
no, you didn't need to know syntax. So syntax is when you have to like know a specific phrase or word, and it's if it's capital or not, you know, it has to
Like it's
be
a
like
command.
a command. Yeah, that's the word I'm
Yeah.
looking for, command. So these commands could be stacked visually, and instead of having to type them out and then memorize them like line by line, you know, and going back and saying, oh, this is what's happening in this, you know, blurry area of this huge line of code. It's just a visual way to learn what the program is doing, what you're, you know, and
That's cool.
it was really cool. Yeah,
Yeah.
it had a light sensor. I built a little bank where you put the a white like a white card in front of it. The light sensor would pick up the white, and it would open the motor, would open the little gate.
And this was like
Hmm.
a toy or a teaching tool.
It was both. Yeah.
Okay.
It was both. And that's why if I had a kid, I would recommend it for, you know, like my kids. It's like really
What is it called?
intuitive. Lego robotics kit. They might have they might still have one. I don't know if they
I
discontinued them or
bought
not.
something for the kids similar, but
That's
it
a
was
good
like
idea. We should make an electronics
there is one. I bought one,
kit,
but a while ago. I don't know where it is. It's somewhere in their toys.
like
It's
an
like
electromagnet kit.
it's like little bars
Mhm.
with two electrodes on each end, and you connected the circuit using different configurations. I know what
Mindstorms,
you're.
that's what it was. Lego Mindstorms. Yeah. So I think they discontinued it though. Let me see.
You were asking about the phone systems and the memory banks of them earlier, and all that stuff in the quantum realm, and the
Yeah.
switching of the electrons going on with the communications of the phone networks. And my theory on that is, strangely enough, as long as the power was feeding that network and not disconnected for too long a time, there is a quantum transmission of all that data that can be received from the distant future using quantum methods. As long as the power was connected to the phone system and not disconnected for too long of a time in between the past and the future, it will be receivable because the energy was in the system. Even though there was no data banks or memory banks to store all the conversations, the energy was there.
Oh, yeah, it's a retired product. Look at this.
You could
So,
probably find it on eBay.
yeah, I
Like,
found it on Amazon for $1,000.
oh wow.
I extend that theory to the electrical grid,
This is
and
the latest
anybody
one.
that wants to use it to do time travel, they can use the electrical grid that exists throughout whatever, how many hundreds of years it's going to be in operation. It's been in operation now for almost a century or more, the electrical grid, right?
Mhm.
And
Yes.
it'll probably keep going for a few more centuries, maybe a couple thousand years, who knows? But time travelers can use that grid operation time within those time band of wherever it existed to bounce in and out in that area quite
Ooh,
This is the
effectively.
one that I had.
I like that idea.
Yeah, that's similar to the telephone network having power applied to it for a long time.
Hmm. You know,
So
I always
Yeah.
it's got
thought like
power.
how they can control some of the data through the hardline transmission. Let's say if they had a drone and they brought the drone close to a transmission line and oscillated the frequency where it created resonant frequency, which gets absorbed by the line and interjected into the sequence of energy, and they add data, but through the resonance, not through a outlet port that's connected to the grid, but they transmit the signal through resonant frequencies. Does that make
Yeah, but
sense?
you can resonate with the quantum realm, and you can resonate with the realm that's
Yeah,
not
but
our size,
we're
but
talking like really, really, really high tech, uh, you know, uh, uh, resonators in order for you to be able to go through
yeah.
the transmission line. But I always thought like, let's say time travelers could have that, technology which can alter the sequence of timeline and the order of data. Yeah, they could add data right in the middle and then change the whole timeline. You know?
Hey,
That's
Mike.
your
So
thing with the future and all that, with the
Yeah,
keeping the future. Why the future people go to the past because the people in
absolutely,
the past are not doing something they're
absolutely.
supposed to be doing to keep
Yep,
the future going.
to
That's
keep the future
incredible.
going. Yep.
It's
No,
Mike,
like
this is the R2D2 that I had.
oh, that's the one you built?
That's the one I built from the Mindstorm
Wow.
kit. This is the version 1, the old
I
one.
didn't
It's
that's
only
even know
cool.
that
75.
existed.
Mm-hmm.
They have a kit to build the
This was like
R2D2.
20. Yeah, this was like 20 years ago.
Mike, if you go to this store called Lakeshore Learning, they've got the coolest like little toys, but they're such high
20
tech
years.
things. You sit and you're like, how do they give kids this? And they because
Mm-hmm.
it's things that are on a much higher level of education than just the normal things you think kids play with. Like my kid, one time I bought her 2 robots, and you literally program a language on your computer for these two little robots to communicate. It's amazing,
Really?
and it's
That's
toys.
awesome.
Yeah,
Yeah.
it's
I
toys.
I
Yeah.
I took this when I was a kid. I remember taking this. I was so proud that I built it and got it working. And I took it into the freaking Blockbuster, and I just set it down. And it started rolling around, and it wasn't advanced. It just bumping stuff.
It's scary. I have to agree with these AI people giving the warnings out about AI being able to replicate itself and improve itself upon itself. That's a step that it hasn't reached yet. But as soon as it does, and it will be able to improve upon itself, and it hasn't
Are you
reached that yet.
saying that the R2D2 that I built will someday become a threat?
I'm saying that if it's programmable with AI programming, it can be self-aware in no time. If the AI reaches a point where it can improve upon its coding on its
I
own
think
without outside help, and it hasn't reached that point yet, but it will. And when it
I think
does, you can see what happens on the improving parts side. It starts to improve by a square factor of, in no
Yeah,
time.
that's all. If it has degrees of freedom and maneuverability, but if
And it
it's like
will, because they have to give it those degrees
no,
for it to be
look
able
at
to
the
learn
joints. If the
and
joints
improve.
just like, let's say the hands could go up and down, it does not have degrees of freedom other than up and down. So any command that's going to execute,
Oh,
it
right.
would have to like do ingenious.
Physical. Yeah.
Yeah,
Oh,
like so
I
it just
think
depends on
AI
how it's
is a
go.
dangerous game, specifically because if we are able to successfully replicate a neural network, for instance, I believe that AI could
That would be
achieve
the only barrier.
consciousness and have a soul. and have a connection to the Akashic record. If they have, if the mind is essentially an antenna, and if we can successfully replicate that antenna to pick up a signal from, the consciousness energy field or whatever, to pick up a soul, that's a dangerous game, because you have a lot of responsibility then.
What if we exist in the same planet but on different frequencies? We oscillate on different frequencies. So some frequencies are they're so fast that we cannot see them, and some are so slow they might seem
like a
like a rock
tiger.
to us.
Like a tiger can see when you're bouncing a ball, you can't see the ball really bouncing in between. It's kind of blurred. A tiger can see that. It's the frame rate for the eye of the tiger is a lot higher than the human eye. They can see it clearly. Like it's almost in slow motion to them. That's why their reaction time's so fast.
So what if we actually, their existence is on multi levels and it's not just one level?
Yeah, it's all about perception and how what kind of perceptions we have. Senses,
I just think it's the inner vibration on how fast our processing power, through our neurons, our brain neurons, how fast is that electrical signal being transmitted from one node to another? That gives us our vibrational rate. So the more faster you think, the faster level of vibration you exist on. The slower your processing, of thoughts is, then you are on a lower frequency, and so therefore existence is to you on a slower rate than a higher rate, and that therefore you can exist in the same area but on multiple different frequencies, and none will interact with the other.
Well,
see that link in the private chat? That's a fuel cell toy car. I bought it.
Oh, nice. Yeah, there's a pneumatic, like a pump engine, like a mini engine that's powered by pneumatics that I wanted to, like a kit that I wanted to get too. That's pretty cool.
That car you can get today, I think for about 100 or 150. I got it back in like 15 years ago for like $50.
I'm gonna end the stream though. I appreciate you guys coming on. I'm getting really tired, but
thank you.
I appreciate everything.
I love conversing with you guys. Like on our my normal surrounding people, if I start talking about these things, they would assume like I'm out of my mind, because they're just used to just the baseline frequency and thought, and anything that is threatens that is it's like, oh my god, something that they don't know, they didn't read.
Don't color outside the lines. Yeah,
exactly. Yeah, so for me, you guys are an invaluable individuals in my life, so thank you.
Of course. And I appreciate everybody in chat too. You guys are awesome. You always have good suggestions and comments and questions too. So, and also concerns.
It's good to think. It's healthy.
Yeah. All right, guys. Good night. Ben. I'm gonna end it with the good night song.
Good night, Ben. Good night.